Hi everyone, welcome to Vedantu NEET English. I am 𝐂𝐡𝐞𝐤 your chemistry master teacher. Yes, everybody, very good evening. And how are you, everybody in the chat box? Am I visible? Am I audible to all of you or not? So, guys, today we are going to do structure of atom, right? A very important chapter. It forms a base of chemistry actually, right? You get to know what is exactly this atom, like how we know the structure of atom, right? And the electronic configuration, right? That is used in like full organic, inorganic chemistry, not in physical, but yes, it is used, right? So if you don't know structure of atom, that means your base of chemistry is very weak. Now today we will see what kind of questions they ask you, right? Because guys, see, I have made these handwritten notes specially for you, as you can see here. Wait a second. Okay, so I have made these handwritten notes already for you, right? So these notes I have made so that we can, manage the time, because it's a very big chapter, right? So I just wanted that in less time we should do more practice, more questions, and we can revise things in a very efficient way. So I have already made this handwritten notes only for you guys, okay? So now I'm going to teach through these handwritten notes, and those students who don't know this thing, that there is NEET Express batch going on, right, which has just started, right? In this NEET Express batch, we have basically what I'm teaching you, right? Okay, in a similar pattern, it will go, right? So here basically we have, if you talk about Prime, NEET Express Prime, here I'll teach you live sessions, online classes, online tests will happen, online tests and practice pedagogy will be given to you, V-Buddy will be given to you. But you will not get test series, you will not get crash books, you will not get unlimited access to Doubt app. But if you're enrolled to the combo batch, then in addition to everything that I have mentioned in Prime batch, you will get test series also, all India test series also you will get, which is a very important. At this point, 5 months before, you should have started your test series. Why? Because guys, this high time. If you don't know, like, what are your mistakes, what you are lagging behind, then how can you improve those mistakes, right? You are not antaryami, right? So next thing is, if you want to get not only the test series, but you also want to have a teacher that is like 24/7 available for you, then you should enroll to NEET Express Pro batch, right? Okay, so that's totally your choice what you want to enroll to, right? Here we have also mentioned the prices of the respective batches, right? Okay, this is for 2999, 4499, then 8999, right? I would advise you at least go for combo batch, right? But if you're revising in between, you're also working on your backlogs, then my advice will be Pro, because there you will also get a doubt app where you can ask the doubts 24/7. That will really help you when you're solving the test series. Then you have some doubt, obviously you will do some mistakes, you have some doubts while practicing questions, then you can definitely ask that within seconds, right? So I would advise Pro, but at least go for this combo version, at least go for this, okay? Chalo. Now let us start the session. The session is structure of atom. Now I want everyone green hearts in the chat box for structure of atom. A very important chapter, interesting chapter. So many concepts are linked to this chapter. Right? We will start with the atom. We will study about the discovery of atoms. Then we will go towards the models of the atom. Rutherford model, Thomson model, very simple. But after that, we will move towards the dual nature, right? Black body radiation, Planck's theory, Broglie equation, Heisenberg principle, what not, right? We will study. After that, we will jump towards Bohr model, then quantum theory. In quantum theory, today only I'll also teach you how to calculate the radial nodes, angular nodes, but just by seeing the diagram, right? Okay, by seeing the graph. In the graphical methods also we will revise how to understand, and those students who have not watched my previous lecture also on structure of atom, this is the best way. Reason being, there I have covered all these things maybe in 2 lectures, right? around 8 to 10 hours. But now I'm going to complete this within 3 to 4 hours, right? Along with the practice questions, right? Okay, so are you all ready for this? Okay, so now let us start. Okay, now let us start this. Now the first thing is, so many experiments were going on for the discharge tube, right? So firstly, if you talk about the atom is basically, we know that atom consists of three things, right? It consists of three things, and what are these three things? It is neutron, it is proton, and it is electron. I know there are also other particles like quarks and all, but that is not in your syllabus, right? NCERT, they have not updated those things in your syllabus, so congratulations for that, right? But in detail, if you ever study, if you ever like do PhD or maybe MSc, then you have to study about quarks, all of these things also, right? But in your syllabus, in our NCERT, it has just updated till neutrons, protons and electrons, right? There is no discussion about that, how neutrons are made up of how many things, protons are made up of what and what things, and electrons are made up of what and what things. That is not in your syllabus, right? So stick to neutrons, protons and electrons. So firstly, what we will study that how we know that the neutron and proton is inside the nucleus and the electrons are evolving around it. That means we will study about the atomic models. Right? Then we will also study about the discovery. How we know that in an atom you have electrons, you have protons, you have neutrons. There must be some study related to it. Okay. So firstly, let us talk about the study. The discovery. Firstly, we will talk about the discovery. So it was not a well prepared study. Okay, let's discover electron today, right? It was not that kind of discovery, but it was accidental discovery. At that point, it was very famous. Okay, let's do experiments on discharge tube. So everyone was doing these experiments on discharge tube. That is how Thomson, right? That is how Thomson did an experiment on this discharge tube, and he found out some negatively charged rays which turned out to be the electrons, right? Now before that, you need to understand one thing, that air is an insulator, right? Because inside that, if we have inside the discharge tube, if we have air, right, in that case of whatever gas we are putting inside the discharge tube. So basically this is your discharge tube. Okay, this is your discharge tube. So inside this discharge tube, if you have a simple air, right, you don't have a defined gas. Now, is this a good conductor of electricity? Will it produce electrons? Will there be any flow of electrons or not? For this, Crook has experimented on this thing, and he said that air is an insulator, right? That's why, okay, current, for example, some electricity, right, that is some current or maybe some wire, some electricity, right, that is producing on this particular channel, right? So now I am standing here. If air is a conductor, then I would also get that current, right? Okay, I would die on that instant only. But this doesn't happen in reality. That means air is actually an insulator. But when we talk about in discharge tube, if we have low pressure and high voltage, so that is why discharge tube experiments will have these two conditions, that is high voltage and low pressure. If in that discharge tube you have very high voltage and very low pressure, in that case that air will behave as a conductor. Okay, that air will behave as a conductor. That is why you have condition of discharge tube experiment. Condition of discharge, whether you talk about the experiment for cathode ray or anode ray, you will get this thing only. That first thing is the voltage should be very high, right? The voltage should be very high. Then the pressure should be very low. There should be low pressure, right? The pressure should be very low. These are the two conditions for your discharge tube, right? Now, let us talk about how electrons were discovered. That is our first subatomic particle, right? Discovery of the electrons. So now these electrons were discovered by this particular experiment where you have two things. One is your cathode and one is anode. If I say this side is my cathode side, this side is connected to a negative side, this is connected to a positive side, and now I am saying that, wait a second, now I am saying that the side which is the rod that is connected to the negative side of the battery, that is called cathode. So I'm just going to write here, this is cathode. Okay. Now on this side it is connected to the positive terminal of the battery. That is why it will be called as anode, right? It will be called as anode. Now what he did here, three things that you need to remember. What he did here, he said that what he observed, that when he had a zinc ZNS screen, fluorescent screen over here, very fluorescent screen means, ZNS fluorescent screen means whenever a charged particle will strike on that, it will blink. Okay, whenever a charged particle will strike, it will blink. Right, that will give us an idea. Otherwise, these rays are invisible. They are not visible. Right, they are not visible. Right now, we have some technologies because of which we can see these rays. Right, but otherwise, at that point, it was not visible to us. Right, we didn't have that technology from where we can see the cathode rays. That is why a ZNS screen was plated over here, so that whenever these rays will strike, it will give us a blink, it will give us a striking. Right, now what he did, he said that this particular anode that you have here, this anode, let's draw anode like this. Okay, this anode that you have here, he said that make this anode as perforated. Right, make this anode as perforated. Perforated means there should be holes in between this anode. Right, there should be holes. Now for example, you want to go somewhere. Right, now what there should be some door, or you are superhero, you can just cross through the walls. You can't cross through the wall, right? You need some door, window, anything there. Only then you can jump from one side to other side. Right, similarly, if these rays want to touch the ZNS screen, then we should give holes over there, we should give them the passage, so that these rays that we can see here, they can pass through these passages and they can give us a blink on the ZNS screen, right? That was the overall experiment. Now, second thing is, ma'am, why we name it cathode rays? Because they are coming from cathode side, from cathode to anode side they are moving. Second question is, ma'am, how can we say that these rays are negative? Like I have written here, these are invisible rays that I told you. That is why we have ZNS screen. Second point here, we have written negative charge particles. Now the question is, why we have negative charge particles, right? How can we say that this is a negative charge particle? See, this is the positive plate, this is the negative plate, right? Now, if we know that like attracts, we know that opposite attracts each other, right? So, from that we can understand that if something is positive, it will get attracted towards negative. If something is negative, it will get attracted towards positive. So, if this ray is getting attracted towards positive plate, that means definitely this ray has some particles which are negative in nature. That's how we say that the cathode rays have negatively charged particles in it. Now today we call these negatively charged particles as electrons, right? Okay, so these are our electrons. Now, next thing that we can see here, it is moving in a straight line. So this is a very, very important point, okay? This is a very, very important point because a proper experiment has been done on this particular point. That is, it is moving in a straight line, right? So, how can we say that it is moving in a straight line? Let me show you a diagram based on this, right? Can you see this diagram? This is directly from your NCERT only. Can you see this diagram? Very good, very big. I love the Josh in the chat box. Now, as you can see here, he did an experiment. You don't need to get into that much detail of this experiment because hardly any question will be asked from here. I am telling you the crux of all these things, that what question can be asked from here. What question will be asked based on the electrical and the magnetic field? What he said that whenever you had no electrical or magnetic field, this cathode ray is passing straight, right? This is straight. But when you apply electrical or magnetic field, it will deviate from its path, right? It will deviate from its path, right? If it is moving upwards, that means you have applied electrical field. If it is going downwards, that means you have applied magnetic field, right? So basically, what question can be asked? That cathode rays can be deviated. What is the what is the condition that they can be deviated? If you have electrical or the magnetic field, then these cathode rays will be deviated from their path. Okay, otherwise they are moving in a straight line only. Otherwise they are in a straight line only, right? Last one is E/m ratio. Now this is also a very important point from where again the questions can be asked, right? Now let us see how I am saying that this is independent. Why I am saying it doesn't matter. You have air, you have hydrogen gas, helium gas, neon gas, nitrogen gas, oxygen gas. The cathode ray is going to remain the same. Why I am saying that? See, if you talk about today, we know the structure of the atom. We know that in hydrogen, you have one electron, you have one proton, right? You have one proton. So from here, can I say that when this hydrogen, this is a nucleus, here you have a proton, here you have electron that is revolving around it, right? Now, here I know that this electron is an individual quantity, right? If I talk about helium, I know it has two protons, right? And two electrons are revolving around it. And these are two definite electrons. Because today we know that proton is inside that nucleus, but electrons are revolving around. Okay, there is not, okay, this electron has to bound to the other electron. It's not like that. They are just moving around in a shell or orbit. All these things we will talk about, right? So that is the reason it is independent of the gas. Whatever gas you take, maybe in helium definitely you will have two electrons, right? In hydrogen you will have one electron. If you talk about neon, you will have 10 electrons. In nitrogen you will have 7 electrons. In oxygen you will have 8 electrons, right? Number of electrons can differ, but the electrons is going to remain the same. It's not like it will change, because one electron, right, if you talk about individual electron, that is going to have the same charge, that is going to have the same mass, right? If you're not able to understand this, then when I do the discovery of proton, it will be like more easy for you to understand with the comparison with the discovery of proton, right? So now how he understood the E/m ratio? What is the value of E/m ratio? What is the value of charge? What is the value of mass? Let us talk about these things here, right? Now this has been done with the help of the charge, everything, the charge, the mass, the E/m ratio. All these 3 points are important, right? But how he discovered this thing, right? That was by Millikan oil drop experiment, right? Okay, that was by Millikan oil drop experiment. Millikan oil drop experiment. Now let us see what is this Millikan oil drop experiment, right? It is also not that much detail in your syllabus, but you should understand that, because they can ask you question from a very basic formula. They can ask you question from Millikan oil drop experiment. So just go through the diagram. Okay, I'll just give you the conclusion of what they are telling you in that experiment. Okay, from that we discovered the charge and E/m ratio, right? First thing is, what is the charge? 1.6 into 10 raised to power minus 19 coulomb. What is the mass? 9.1 into 10 raised to power minus 31 kilograms. What is E/m ratio? You just divide these two things, and what you will get, this is your NEET question only, right? This you will get 1.75 into 10 raised to power 11 coulomb kilogram. This is a very important value to remember. Okay, very important value to remember, right? Okay, now let us see We will also talk about these things, but before that, let us see the Millikan oil drop experiment. So can you see this diagram, everybody in the chat box? Can you see this diagram? Okay, I'll just tell you that what exactly they are telling you in this particular diagram. Okay, are you able to see this, everybody? Everybody, thank you so much, thank you so much. Okay, so now this is the diagram, as you can see here, Now, usually students skip this, okay? But let me tell you, it's a very easy thing. It just looks very tough, but otherwise it's easy only, right? So basically, it's based on a simple method of balancing things, right? So what will happen from the atomizer, right? Okay, this is the atomizer, right? From what will happen, you will have the oil drops here, right? You will have the oil drops here that will be sprinkled here. Now, here you have a small hole. Here you have a small hole. And from this hole only, this oil drop will go downwards, right? And here you have the charged particle, right? Here you have the charged particle on this plate, right? Okay, that is the charged particle that you have. Now, what will happen when it is going down? When it is going down, this is the oil drop, right? That we are observing. This oil drop is going down. It will catch. It's like whenever you are, like someone is throwing ball at you, you will catch that ball, right? So in the similar way, this oil drop, it will catch that charged particle, right? Okay, so it will catch that charged particle. So basically what you will have, if I am saying this is the oil drop, this is the oil drop. So in this oil drop, you will have the charged particle also. You will have the charged particle also. Let us say it is M positive. Whatever particle I am talking about, M positive I am saying. So this is the charged particle that it will catch. Now what will happen? The electric field here, right? This is the electric field. Now here you have X-ray from the source. Basically from this source only you will have that particle, right? So now what will happen? From this is the charged negative plate, this is the positive plate. Because of this positive plate and this negative plate here, can you see that? This is the positive plate, this is the negative plate. Now can you tell me what kind of field it will produce? Can you tell me what kind of field it will produce? It will definitely produce, okay, you guys are not able to see. That's not that much, huh? Wait a minute, let me just show you what exactly you have here. This is a chamber, right? This is a chamber, right? Like a beaker only, right? Now, in this beaker, you have a source of X-ray. From this source of X-ray, you will have the particle like electron, right? From this source of X-ray, you will have the electron particle because you want to calculate the charge on the electron, right? So, you need to have a source of electron also, that is the X-ray from the source, right? Now, it will produce the charge on this side. It will give the charge on this side. And here you will have a hole. And this is the charged plate. This is positively charged plate. And this is your negatively charged plate. This is your negatively charged plate. Because of these charged plate, you will have the electric field here. You will have the electric field here, right? That is the first thing. We know that one more force that is working here is gravity. That is gravity. Now, electric field will try to balance the oil drop here. So, now in this oil drop, what you have? In this oil drop, what you have? You have one electron that it has caught. The electron is coming from this side, oil drop is coming from this side, right? So, they both have shaken the hands now. Right, so now in this oil drop, you have this electron also. This is the oil drop that I am mentioning here. This is the oil drop that I am mentioning here. Now this oil drop will become static. That is the main thing about this particular experiment, that this oil drop will become static because of two forces that are going to balance each other, right? So first force is gravity, that is going downwards. It is making that oil drop to go downwards because of the gravity, but the electric field wants to make it like it wants to go upwards. So it will balance it, right? Because of electric field, it will go upwards, and that is why this particular oil drop, it will become static. Now, it depends that how many. Now, tell me firstly, till here, are you able to understand what exactly is this experiment? Are you able to understand? Guys, are you able to understand? Now, I'll tell you that how they actually found out the value of charge from here. First, you tell me, are you able to understand this thing or not? Everybody understood? Now, this was the whole experiment. Now, the next thing is, ma'am, it's not like necessary that this oil drop will only catch one electron. It can also catch 2 electrons, 3 electrons, 5 electrons, 10, 20, 30, 40, like I don't know how many electrons, right? N number of electrons it can catch, right? So there can be so many electrons over here, there can be so many electrons over here, right? Okay, so I'll just say it has n number of electrons. So the charge on the oil drop is equals to n number of electrons and the charge on the electrons, right? Now, what from this particular equation only, he calculated the charge, this value of this E from this side, right? By the number of electrons, calculating experimentally the number of electrons, then the total charge from the experiment only, the total charge was Q on that oil drop. Q is the charge on the oil drop, N is the number of electron that it has caught, and E is the charge on one electron. From there, he calculated the charge on the one electron. Okay, understood? So in the exam, you just need to understand that what was there and this particular formula, that Q is equals to NE. What they can ask you, that maximum what they can ask you in from Millikan oil drop experiment, that you have a, maybe they can ask you that the charge on the oil drop is X, right? Whatever value they have given you. Let us say it is 12.96 into 10 raised per minus 40. I'm just randomly I'm taking some value, right? Now they are asking you the number of electrons there. So it will be N equals to Q by E. What is E? This is 1.26. Q you can put here. What is E? E is 1.6, right? Okay, so just put the value here of charge of electron and you will get the number of electrons here, right? Okay, right? Yes, this is the starting part only. Yes. This is the starting, but it's only 10 minutes I have started, right? Okay, understood everybody? Right, so that was your Millikan oil drop experiment. Okay, that was your Millikan oil drop experiment. Right, from here we calculate, I am writing it here also, right? The value that you need to remember is Q is equals to NE. That is the formula that you need to remember. Q is the charge on the oil drop, right? Now, what ma'am you have written here? What is this? Deviation of cathode rays is directly, I told you one thing, that here you will have the deviation of cathode ray. So, understand one thing firstly regarding the electric and the magnetic field. If the electric field is very high, that means the deviation will be very large. If the magnetic field is very high, the deviation of the cathode rays will be very large. So, this we have written here. The deviation of the cathode rays is directly proportional to the electric, is directly proportional to the magnetic field. Second thing what I have written here, deviation is directly proportional to the charge here, right? The more the cathode ray means more the number of electrons in the cathode ray, more will be the deviation, right? Okay, more the charge, more will be the deviation from this side and that side, right? Okay, now what about mass? If someone is very fat, it will be difficult for them to move, right? So in the same way, if the mass is very high, in that way the deviation of the cathode ray will be small. Okay, the deviation of those cathode rays will be small if the mass is very high, right? So that was the like proportionality I told you, that okay, from here also the question can be asked. Okay, so that was the discovery of electron. We have discussed Millikan oil drop experiment, we have discussed deviation, right? We have discussed the cathode ray experiment as well, right? Okay, understood? Now let us talk about what is this discovery of protons, right? Okay, so it is quite similar only, as you can see here, quite similar. Can you see the diagram here, right? Now from here, as you can see, now things are opposite, right? Now things are opposite. For to make you understand that thing, I would like to tell you one example, that here, for example, let's talk about hydrogen, which has one electron and one proton, right? Now, in that atom, you had one proton inside the nucleus and you had one electron. Now, when you did an experiment with the cathode, see, obviously, even in this experiment, what is happening? I have not put zinc screen here. I am putting zinc screen on this side now. I am putting zinc screen. This is the zinc screen, okay? I am putting the zinc screen on this side now, right? Not on that side, right? This is my ZNS screen. Now, tell me one thing, that if in this particular apparatus, right? If in this particular apparatus, okay, tell me just one simple question. If I am saying you guys are NEET aspirants, is this possible? If I am saying that you guys are going to give, this is possible that someone is NEET aspirant is in 6th class, right? Definitely that is possible nowadays. But just imagine you are giving your NEET exam like in NEET 2025, but you are only 8th pass. That's not possible. If you are giving NEET in 2025, definitely you will give your 12th boards before Feb or March 2025. Right? That is, so we already know that should be there. So similarly, if I am saying that here I am testing the positive things, right? The electrons I have tested. Now I'm talking about the protons. Now he is saying that if you have put this thing in this apparatus, then definitely one atom, if let's talk about hydrogen, it had one proton, it had one electron. We know that the electrons are moving towards this side. That means the electrons have already moved on this side. It's just that I don't have ZNS screen here, so that those electrons are not visible to me. Because right now my focus is on the positively charged particle. So if I put one more ZNS screen here, what you will see, you will observe that actually what happened. No, actually what happened, if you put one ZNS screen on this side and one ZNS screen on this side, you will see the glow on both the sides. That means on both the sides, some charged particles are striking here. On this side, though, we know that electrons are striking here. So what will happen in this hydrogen? If I talk about this hydrogen, one electron will be taken out because of this experiment. It is towards the anode side. Now this positive side, this positive thing, that is a proton. Now hydrogen has lost one electron. It has become H positive, right? For example, I am talking about helium. Helium is having two, wait a minute, hydrogen, helium, no. So helium is having two electrons and it is having two protons. And it is also having two neutrons. Today we know that it is having two neutrons, but at that time they didn't know that it has neutrons also, right? So if I talk about just electrons and protons, we know that after losing two electrons, it will become helium 2 positive, right? If I talk about nitrogen, if I talk about oxygen, after losing the electrons, they all will become gaseous ions. So can I say that they all will become gaseous ions? They all will become gaseous ions. A very interesting thing he observed. What he observed, that by taking different gases, this positive things that are moving towards the cathode side, right? That are moving towards from anode to cathode sides, they were changing. That means this anode rays or canal rays, right? They are dependent on the nature of the gas. By changing the gas, the particle was changing. Can you tell me why it was happening? Why by changing the gas, the particle was changing? Because when we talk about a atom, we know that the protons are inside the nucleus, right? We need to have very high energy to bombard on it and to take out the protons from that. Otherwise, with normal energy, it will not happen. That is the reason it is very difficult to take out proton from the nucleus. And that is the reason we didn't get individual protons, positive, like for For hydrogen, though, definitely this is a proton. This is definitely a proton, but because it is having only one proton. Because hydrogen, after losing one electron, it has become H positive. So that means it is only left with one proton. So hydrogen positive. The gaseous ion of hydrogen is proton, but the gaseous ions of others are not proton. For helium, it is 2 into proton. Right? For nitrogen, it will be 7 into proton. Right? Okay, understood? For nitrogen, it is 7 into proton. Because nitrogen is having 7 electrons, 7 protons, 7 neutrons also. Let's say it has lost 7 electron. Let's say that we have given it so much energy that it has lost all the electrons, right? Then it will become nitrogen 7 positive. Now this nitrogen 7 positive, it has 7 protons. That means the positive anode rays or canal rays, they didn't have all the protons, but they either had the fundamental particle proton like hydrogen gaseous atom, or they will have the multiple of proton, right? Multiple of one proton. Okay, that is why on changing the gas, this anode ray particle or this canal ray particle was changing. That is why we don't say that in discovery of proton we had actually all the gaseous atoms were giving you the protons. No, right? It was giving us this anode ray is actually made up of gaseous ions. For hydrogen, this gaseous ion is nothing but it is proton only. Understood? Yes, everybody? Yes. Okay, understood this thing, guys? That if you have gaseous ions, these anode rays, this question can be asked, anode rays or canal rays are not protons. They are gaseous ions. But for hydrogen, that is proton only. And for other elements, it is a multiple of proton. Okay? Yes. Now, let us talk about, this was the experiment. Otherwise, so high voltage, low pressure. For low pressure, we have vacuum pump here. This is anode, this is cathode, and this is discharge tube. Right? Now, let us talk about what is the discovery of neutrons. Right? Okay, discovery of neutrons. So, it was done by Chadwick. Okay, it was done by Chadwick. Now, what he did, he had beryllium sheets and he bombarded these beryllium sheets with the alpha particles, right? With the alpha particles. And what are these alpha particles? These are helium-2 positive. If you take out 2 electrons from helium, right? We know that helium is made up of 2 electrons, 2 protons, 2 neutrons. If we take out 2 electrons from helium, we'll be left with 2 protons and 2 neutrons. So, 2 neutrons, 2 protons, and that is why this is the alpha particle. So, helium is actually, helium-2 positive is actually your alpha particle, and that is having 2 protons and 2 neutrons, right? That is why when we bombard these alpha particles on the beryllium sheet, right, what will happen? We will get neutrons and we will get carbon-12 isotope here. Right? This question also can be asked, that how you had the, though it has never been asked, but it can be asked, right? Okay, so you need to be prepared for all the things. Okay, so now what kind of question? That beryllium, on beryllium, the alpha particles were bombarded, right? Here they can also write helium-2 positive, right? It was bombarded and you got carbon-12 isotope and you got neutron. That was the discovery of this particle neutron, which has zero charge, but it had mass almost same as proton. It had a mass almost same as proton. And you know, today we know that the neutron is present in the nucleus and the electrons are in those circular orbits, right? This is today we know these things, right? But at that time they had no idea about it, right? Okay, because simultaneously scientists were giving models based on the discoveries, right? Okay, now let us talk about the E by M ratio here. Let us talk about the E by M ratio. E by M ratio, they can ask you the order here. The E by M ratio is electron, then you have proton. Proton and neutron is, proton is more as compared to neutrons, right? Okay, because there is zero charge on the neutron. That is why it will be zero only, right? Okay, so first is electron, then proton, then you have neutron. That is the E by M ratio order, right? That is the order of the E by M ratio. Now, that was about the discoveries. Now let us talk about alpha, beta and gamma particles. Okay, alpha, beta and gamma particles. From here also the question can be asked, a very simple question based on the speed or the ionizing power can be asked. Okay, so for that you need to have knowledge about what is this alpha, what is this beta and what is gamma particle. Okay, now, let us see what is alpha, what is beta and what is gamma particle. Alpha particle, as I told you, this is nothing but this is helium-2 positive. It has it has two protons and two neutrons. When you take out two electrons from the helium, we have the alpha particles, right? All of them, they're very radioactive. They have very high energy. But if we compare the energies here, the energy of gamma will be maximum, then you have beta, then you have alpha. Okay, so here also I have written highly active, here also I have written very high energy, here also I have written high frequency. So all of them has high frequency, high energy, but gamma has the maximum, then you have beta, then you have alpha. That is a very, very important point, right? First is alpha, that we have done. Next is beta particles. So if you talk about the beta particles, okay, in beta particles, electrons from inner nucleus, see inner core nucleus, we know that there are outermost shell, there are inner core electrons. So if you take out the electrons from the inner core, then we will get very energetic electrons, and these are called beta particles, right? Okay, negatively charged, negligible mass. As we know, electron has negligible mass, but this should be from the inner core electrons, right? We are talking about inner core electrons. So whenever we bombard, whenever we split a neutron, right? Wait a minute, yes. Negligible mass, no, this is not a right line. Okay, so I'll just erase this thing here, right? Okay. Now, next we have the gamma particle. So if you talk about the gamma particles here, you need to understand one thing. Gamma particles are highly energetic. They have very high energy, right? And they lies, when you talk about, when we will talk about electromagnetic radiation, gamma rays will be towards that end which will have very high frequency, right? So high frequency end of EM waves, no mass, no charge here, right? So as you can see here, this is speed. Now this is important for you, and this is also very important, right? If you talk about the speed or the penetrating power, as I told you that gamma has high energy, that is why the speed is also very high. If the speed is very high, that means they will penetrate into the sheet or anything very fast, right? So that is why mostly alpha particle are used for that. Reason being because they have low penetration power, so that we can study, we can experiment and study that experiment, right? So that is why this is alpha, beta and gamma penetration power. And what about ionizing power, right? That means to ionize, to get ionized, to produce the electrons from there, then gamma, that is totally opposite of each other, right? Alpha has maximum, then you have beta, then you have gamma, right? Okay, so that was about the speed and penetrating and ionizing power, right? Now is atomic models. Let us talk about atomic models now. Till here any problem, guys? Till here any problem? Till here any problem? Any problem till here, guys? That you need to ask Shreyas sir. Okay, That you need to ask Shreyas sir about it. Even though I have forgotten Fleming's left hand, right hand rule, I know something like this was there, right? Okay. Now, you think I am all rounder. I know physics as well. No, I don't know physics, guys. Okay, I am very bad in that. Okay. So now this is the atom, right? Okay. Now, this is the atom. This is very, very simplest thing of your 11th class chemistry, that is Thomson model. He said that it is like a watermelon, or he also called it as plum pudding model. I'll just write it here. He named it as watermelon model. Also named it as plum pudding model, right? Why it was so? He said that, like in the watermelon, if you have in the watermelon, the reddish part that we eat are actually the proton, right? That means he said that the proton is distributed uniformly all over it. So in watermelon, the reddish part is the proton, which is distributed uniformly, which is distributed uniformly, right? Then he said that now red part is proton, it is distributed uniformly throughout the sphere, atomic sphere. He said that the electrons are like seeds. Right? That are penetrated in that sphere. Right? So these are the two things that he told. Obviously, as you can see, he was not able to tell us that how the electrons can be taken out then. If you are saying that it's like a watermelon, how you can take out one electron from the inner core, right? How it is stable, how the electron and proton, because proton and electrons, they will be, see, proton and electron, they have opposite charge, so they will attract each other. How come this model tells us the stability? So that is why this model was a failure, right? So now this model was a failure. As you can see, positive charge all over, and the negatively charged electrons are embedded here in somewhere. Okay, so they are embedded here, right? Now, next is Rutherford model. Before learning Rutherford model, you should know one thing. While Rutherford were doing this thing, first thing is though, Rutherford was not doing it intentionally, right? It was in the lab, like in factory or lab, right? So in that, the workers were experimentally and they observed something very weird, right? After that, this was done again and some conclusions and observations were drawn here, right? One more thing here, that here Rutherford, at the time of Rutherford, while he was giving us the structure of the atom, there was no knowledge about the neutron. We only knew that protons and electrons exist in the atom. That's why in Rutherford model, he will not talk anything about the neutrons. Okay, so never ever mark that option as correct whenever they are hinting that, okay, the Rutherford model was showing you the neutrons also, was giving you explanation about the neutrons also. That is not right. Okay, so now let us see the Rutherford model, right? So Rutherford model said that, firstly, so let us see the diagram here. From diagram only, most of the things will be clear to you. Now, as you can see here, this circle that you are seeing here, this is actually the ZNS screen. Okay, this is the fluorescent screen that is going to, whenever a charged particle is going to strike here, it is going to give us this glow. So this is your ZNS screen. Okay, this is your ZNS screen. Now, if you talk about this thing here, this is your lead plate, right? So in this lead plate, you have this hole. Okay, this is the hole in the lead plate. Now, here you need the source of alpha particles. This is the uranium, the source of alpha particles, right? From here, the alpha particles will go in between from this hole, right, so that they can pass here, and they will strike on this sheet, which is a very, very thin sheet of a metal, that is gold. Okay, we know that gold is the most ductile, not ductile, it is the most malleable metal, right? So it can be drawn into very, very thin sheets, right? So that is why he used gold, right, which is very malleable, and this is your gold. Now what will happen here? What will happen here? Three observations he will draw from here. Okay, I'll tell you that how he observed these three things. What he observed, that most of the alpha particles, see one thing, alpha particles, we know that they are positive in charge. We know that inside the atom, if you talk about an atom, this is your atom, this is positively charged. If I am taking this as the structure, we know that this proton is also positive, right? So when we will see the repulsion will be because of the proton. When there will be attraction, that will be because of the electrons here, right? Okay. Now what he observed, that most of the alpha particles were moving straight without any deflection, right? So most of the alpha particle went straight without any deflection, right? This is most of the alpha particles. Now some of the alpha particles, right? Some of the alpha particles, they deflected by some angle. They got deflected by some angle, right? And only few means out of 20,000 only one, right? Only few alpha particles got bounced back. They got bounced back, right? So that was a very surprising thing, that why most of the, again three observations here, everybody, three observations here. What were the observations? The observation were most alpha particles went straight without any deflection, without any deflection, right? What was the second thing? Everybody in the chat box, what was the second observation? Most of the alpha particle went straight. Some alpha particles deflected by some angle or deviated by some angle, by some angle, right? And very few alpha particles were bounced back. Now from here, what are the conclusions that we can draw? We can say that if most of the alpha particle went straight, that simply means that the positive sphere that you are assuming is very, very small as compared to the atom. As compared to the atom, it is very small, right? So that is why most of the alpha particles will went straight here, because there will be no repulsion that they will see. Most of the alpha particles will went straight, right? Because here you will have electrons, they will went straight, right? Now some of the alpha particles, why they got deflected? Because they are very near to the nucleus, that is why they got deflected. They were very near to the nucleus, that is why they got deflected. And only few alpha particles, they got bounced back. The ones who were actually striking on the proton, right, that is why they got bounced back here, right? That is why they got bounced back here. So this was the whole scenario, right? Okay, so this was the whole scenario, right? Okay, right? Okay, yes, definitely you can continue here, right? Okay, so that was the whole scenario. Wait a minute. Yes, okay. Okay. Now, what was the conclusion that he drew from these things? Firstly, though, we can say that the proton, right, is present inside. That means there is a term he named it as he termed it as nucleus. So inside the nucleus you had protons. First thing is, he said that inside the nucleus you have protons. Now this nucleus is very small and very dense. Because it is, why it is very dense? Because one ray that touches this proton, it will bounce back. That means this particular nucleus is very small, but it is very heavy, it is very dense. Third thing is, observe that most of the space inside the atom is empty. That means if this is your cricket ground, this will be your Virat Kohli, right? So it is very empty here. That is why most of the space inside the atom is empty, right? Okay. And mass is concentrated. Mass of this whole atom is concentrated on the nucleus, right? Okay. So that was the thing. Now, he could have, like, here I have given you one hint that why this nucleus is very heavy. He told that this nucleus is very heavy. Today we know that why nucleus is very heavy, because inside that nucleus we also have neutrons. That is why it is very heavy, right? Okay, that is the reason it is very heavy. So we can say that, we can draw some conclusions here, that first thing is most of the atom is empty. Second thing is positively charged nucleus we have, which is small and dense. Electrons revolve around the nucleus. These are the 4 points that we can draw from this particular experiment. Now let us see the experimental ways of this thing, right? Okay, that is charge on nucleus. The charge on nucleus is plus Ze. So they are saying that the charge inside the nucleus, you will have because if we talk about nitrogen, it will have 7 protons. So 7 is the atomic number, right? Okay, and this P is the electron. If I talk about the proton, it will have plus E charge, right? So we know that the charge is opposite. Electron has minus charge and proton has the same numeric value but positive charge, right? That is why we have written plus Ze here. Radius of the atom, he calculated it to be 10 raised to power minus 10 meter. Radius of the nucleus was 10 raised to power minus 15 meter. If you divide these two things, that will be 10 raised to power minus 10 divided by 10 raised to power minus 15. It will come out to be 10 raised to power 5, right? And what is the, if we see, we know that what is volume. Volume is equals to 4 by 3 pi r cube, because we are taking atom as almost a sphere, right? So that means it should be 4 by 3 pi r cube. That is the volume of the sphere. So the volume will be r cube. That means the volume is directly proportional to r cube. So if ratio of radius is 10 raised to power 5, the ratio of the volume will be 10 raised to power 15. Okay. And then we have, what are the failure? Now, can you tell me what is the failure of the Bohr model? So, first is the Maxwell theory. Everybody. First is the, okay. Now, first is the Maxwell theory. If you talk about the Maxwell theory here, Maxwell said that whenever you have charged particles, there is electrostatic radiations. What will happen? It will lose or radiate the energy, right? So, if I am saying that here you have proton and electron is moving, that means it is going to lose the radiation, because if there is electrostatic radiation, it is going to radiate the energy, and it will move into the nucleus by the spiral path and it will collapse. But we know that atom is stable. So he was not able to tell us the stability of atom. Why the atom is stable? He was not able to tell us that, right? Because if we follow Rutherford model, then it is opposing Maxwell theory. So either Maxwell theory is correct or the Rutherford model is correct. So that is why that was the limitation, because he was not able to explain the stability of the atom according to the Maxwell theory as well. Second is line spectra. Now what about this line spectra? See, we are saying that there is no discrete energy levels here. We are not talking about discrete energy levels. We are saying that this electron can move in any energy, right? It can have any energy, right? If this is your proton, it can be here, anywhere. Right? This we are talking about. We are not talking about any discrete energies here. If we are saying that this electron can be anywhere, then how come it is giving us line spectras? What are the line spectras? It will exist like this. These are basically the line spectras. Okay. How come it is giving us proper particular point how is this possible if we are taking energy as the continuous, right? So that is why he was not able to explain the line spectra as well. That is why Rutherford model was also a failure. Okay, understood? Rutherford model was also a failure after this, right? Okay. Okay, so we have done two models, right? Now we will proceed towards, firstly, the two basic definitions we will talk about, because this isotopes, isobars, I talked about this in the previous lecture as well, some basic concepts of chemistry, right? One shot for that, and today we are going to talk about isodiaphers, isosters. Okay, the two examples I am going to give you so that you are able to understand that how they can ask you the questions here, right? So let us see how they can ask you the questions here. So if you see this, what is isodiaphers? Where A minus Z is different, where proton is different, but A minus 2Z is same, right? So we have two examples here, right? We have two examples here, thorium and uranium, right? As you can see here, that here proton is definitely different. See, this is 90 and this is 92. So proton is definitely different here, right? Okay, then if we talk about A minus Z, so it will be 234 minus 90, that is 144, and here it is 146. So that means A minus 2Z is also different here, right? This condition is also applicable. But if I talk about A minus 2Z, that will be same. A minus 2Z, that is 54, A minus 2Z, that is 54. So that means these two are isodiaphers of each other, right? Okay, these two are the isodiaphers of each other. So that is the example of isodiaphers. Now talking about the isosters. Okay, so this is the example of isosters, right? So let us see the example of isosters here. So what are the isosters? Basically in isosters, two things are same. Number of atoms will be same. Number of valence, that means outermost electron. Now I am not talking about valency. Valency is the number of electron lost or gained. Valence electron are the outermost electrons here. So let us see whether the number of valence electrons are same, number of atoms are same or not. It has two atoms, two atoms, two atoms. So number of atoms are definitely same. Now let us talk about the valence electrons. For carbon, you have 6 is the atomic number. For carbon, you have 6 is the atomic number, that is 2 and 4, right? 2 and 4, right? What about oxygen? It is 8 is the atomic number, so that will be 2 and 6, right? That will be 2 and 6. Right, this is the old method I am telling you. If you want to see it through the electronic configuration, you can also leave it as 1s2, 2s2, 2p2. We know that in the outermost you have this thing. In the outermost, this is the outermost, that is 4. That is 4. If you talk about the electronic configuration, those who don't know electronic configuration, in the end of this lecture, I am going to teach you the electronic configuration as well. Right, okay. Now, this is 1s2, 2s2, 2p, 4, 4. Right. So, in the outermost, you will have 6 electrons. Right. Outermost valence electrons will be 6. Right. Okay. Now, what about nitrogen? Nitrogen is 7. 7 means 1s2, 1s2, 2s2, 2p, 3. So, in the outermost, you will have 5. Outermost is 5. For other nitrogen also, it is going to be 5 valence electrons. Right? It is going to be same, that is 5 valence electrons. What about carbon? Carbon again, it is 6. So, it is going to be, I am just directly writing it as 2 and 4. It is going to be 4 valence electrons. And nitrogen, as you can see here, 7. So, it is going to be 2 and 5. It is going to be 5 valence electrons. Right? Okay. Now let us see whether they are isosters or not. This is 4, this is 6, this is 5, this is 5. Now if you add these things. 4 plus 6 is 10. 10 valence electron. 5 plus 5 is 10 valence electrons. What about Cn? Is this 10? Everybody, is this correct or not? Is this isostars or they are not isostars? Can we say these are isostars? Can we say these are isostars? Yes, thank you, thank you. Can you say that these are isostars? If this is 4 plus 5, ma'am, this is 9. They are not isostars. But here you have one negative. That means one electron they have gained here. So one more electron will be added here and it will be 10 valence electron because it has gained one electron also. That is the reason they are going to be isostars. Okay, they are going to be isostars because number of atoms are same, number of valence electrons are same, and very important, the size is also similar. As you can see, carbon, oxygen and nitrogen, right, they all have 6, 7, 8. This is the atomic number. So the sizes are almost similar only. Yes, Swati, because whenever there is anion means it has gained one electron. So they both together have 9, but they have gained one electron as a molecule. So outermost electron will be 10 electrons. Okay, okay, synapse. Okay, okay. Yes, guys, understood. We should add one electron. Very good, Soumya. Very good. Now, Swati, is that clear? Very good, Roshni, Sneha, Ithril, Swati. Okay, Swati, I have taken your name. I think now you are at peace. What is this obsession with take my name, huh? Tell me, do you feel like, okay, ma'am has acknowledged us that we are present here? I acknowledge all the students, whether I'm taking your name or not, I am acknowledging all the students who are present here, giving your time, and best thing is you are doing this for yourself, right? For your dream. So I already respect all of you who are sitting here and studying, right? You guys are already like at this point, if we talk about respect in my eyes, right? Okay. Thank you so much, Monisha. Thank you. Okay. Now, let us talk about the electromagnetic radiations. Okay. Now, let us talk about the electromagnetic radiation. The second part, the first part of this chapter is very easy. The first part of this chapter, okay, because it's Swati's first lecture. Welcome to the class, Swati. Welcome. So, first part of this chapter is discoveries, atomic models, and these two atomic models only. The second part of this chapter is going towards the dual nature and understanding the Bohr model. And from here, the questions are asked, right? Now we are starting with a very, very important part of that, most important part of this particular chapter, right? Okay, so are you all ready for that or not? Everybody in the chat box. I want green hearts in the chat box for your Diksha ma'am, for your Chintu ma'am, for your Dosa ma'am. Right, green hearts in the chat box. Are you feeling that we are actually doing things at a very good pace, but I am not skipping anything here? Yes, the Bohr uncle is going to join now, and Bohr uncle is very important for us. He is not that scary, right? But he is very important, right? Yes. Sukanya is welcoming the new students here. Okay. Now, let us see firstly the electromagnetic radiation. What are these electromagnetic radiations? For example, let us talk about the light. Because of this light, you are able to see me, right? You're like, okay, this is our Dosa ma'am. She is standing here. Why? Because I have light. Light is reflecting on my face. That is the reason you can see me, right? So, light is electromagnetic radiation. If the light is going towards this side, then electric and magnetic field will be perpendicular to that direction of the light. It's like this. If light is going to this side, then this will be going towards perpendicular to this. This is perpendicular. right? This particular, if this is my magnetic field is also perpendicular to the light. Electric field is also perpendicular. Magnetic and electric field are also perpendicular. So they are mutually perpendicular to each other. That's what we want to say. In electromagnetic waves, the direction of propagation of that wave is perpendicular to electric and magnetic field, and electric and magnetic field are also perpendicular to each other. That means direction of propagation of wave, electric field, magnetic field, all of them are perpendicular to each other, right? Okay, they are perpendicular to each other, right? Now let us see that what they can ask you. See, I think you have done this in detail in physics, right? So I will not go into that much detail here, but this chapter is also there in your physics, right? So this particular part is more in detail in your physics rather than in chemistry. So in chemistry, what kind of question they can ask you is based on this order, right? That is Rami, 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 Ramiv, Rami, VU, XGC. Okay, Rami, VU, XGC. Now this is the order of increasing order of frequency. Here frequency is increasing, lambda is decreasing, right? This order they can ask you, this is the first question that they can ask you. I would say you can solve this question in seconds, and this can easily be asked in your NEET, right? So this is actually free marks for you, right? So no brain, you need to cram this thing and you can just give your answer there, right? So it is radio, R for radio, M for micro, I for infrared rays, that our body is also emitting in infrared rays, V for visible, all the things that we can see. Wait a minute. Can you see any ray coming out of my body? You can't, right? Because infrared rays are not visible to us, right? Can you see UV rays from the sun? You can't, right? Because they are also not visible to us. Can you see gamma rays? No, not visible. Only the visible range is visible to our eyes, okay? So this is basically VIBGYOR, violet, indigo, blue, green, yellow, orange, red, and a mixture of these will form all the colors that we see in this universe. Okay, so now these lie in the VIBGYOR. Then we have UV, X-rays, gamma rays, and cosmic, right? If you want to see, this is the order of gamma that we have written here, right? Not gamma, this is the order of wavelength that we have written here. You just need to remember that this is Rami UV, Rami VU, right? XGC. Rami VU XGC. That's all you need to remember, that it is in the increasing order of the frequency and decreasing order of the gamma. If you talk about this side here, this is also the decreasing order of frequency and increasing order of gamma, right? Okay, so this is your VIBGYOR. Just need to remember this thing. In the visible range, how we mention this? In the visible range, red will have the maximum lambda, right? Just remember one thing, that red have the maximum lambda. Okay, just remember this thing, red have the maximum lambda. Red has the maximum lambda. That's it. Other things are opposite. Definitely then violet will have the minimum lambda. If red has the maximum lambda, then definitely it has minimum frequency, right? Okay, you just need to remember this thing. Okay. Okay, yes. No play, you can go through the NCERT as well, right? Okay, I have completed the chapters that were must to have from NCERT. Physical chemistry, there is no harm in doing physical chemistry also from NCERT, right? You will be able to understand everything there, right? Okay, now next is understanding the formulas related here, right? So first is electromagnetic waves. For electromagnetic waves, we know that this is basically your wave, right? If we talk about the amplitude, this is the amplitude, right? We know that intensity is directly proportional to amplitude square, right? Then next thing is this one thing, this whole wave is making one wave, and the length of this is called the wavelength. That is called the lambda, right? What is the frequency? Frequency is that in one time period, in a unit time, how many waves you have. For example, I have two waves in one unit time. In unit time, I will say the frequency is 2. We say now how many, what is the frequency of your lectures? What is the frequency of your practice questions, right? What is the frequency of you traveling? So that means how many times you do this, right? So this is basically in one unit time, it is having two waves. So it is frequency is 2. So how many waves you have, and this frequency is called as mu. Okay, frequency is called as mu. I'm just writing it here only, right? Frequency is called mu. Frequency is called mu, and wavelength is called lambda. Wavelength is called lambda. Wave number, I'll tell you what is wave number. Wave number is V, and on that you will have this bar. This is V bar, and what is time period? That is T. Now one thing to note down here, that lambda and wave number are opposite of each other. They are inversely, they are opposite of each other. If they ask you 1 by lambda, that is wave number. Okay, 1 by lambda is wave number. And what is the definition of frequency in 1 unit time, right? In per unit, that means number of oscillation per unit time. That means frequency is equals to 1 by T. That is why this is in seconds, this will be per second, and this is what we call hertz, right? This is what we call hertz, right? Now, next thing is, what is this formula? The formula is C is equals to mu lambda, right? This formula is a very basic formula, and you will use this formula throughout this chapter, right? And throughout physics as well. Now, let us see the next thing, that is Planck's quantum theory. But before Planck's quantum theory, I would like to tell you two things here. First is the dual nature, okay? Dual nature. So basically what happened, what was going on back then? Everyone was saying that, okay, this light is a wave, electromagnetic waves, electromagnetic radiations are waves. Everyone was focusing on that. In physics also, if I remember in my 12th class, I have done this interference, I think Young models, something like that, some kind of derivation like that. You have done diffraction derivations, right? These two you have done in detail in your physics. This also you have done in lower classes. This refraction is also in your syllabus in physics, right? Dispersion also is, you have done this in physics. So basically at that time, we are taking this electromagnetic radiation as a wave, right? We are taking that electromagnetic radiation as a wave. We are saying that it is having a wave nature because it is giving us all these experiments, right? It is giving us positive result for that, right? Now, if you see that, they are saying that if you are saying that because of these experiments, it is having a wave nature, then there are also other experiments which is not in favor of wave nature. What are these experiments? That we will study about, because here we are moving towards the duality, right? We are moving towards that thing, that electromagnetic and electromagnetic radiation is both particle and wave, right? So which thing is not supporting the wave nature? We need to study those things in detail. This you have studied in physics, this we will study here, right? That is black body radiation, photoelectric effect, heat capacity, that we will study in thermodynamics. So that is not in your syllabus. This will not study, but this is one of the factor, okay? Then line spectra, right? Okay, these three things we will study. So firstly, let us talk about black body radiation, right? Okay, let us talk about black body radiations. Okay, firstly, let us talk about black body radiation here, right? Okay, yes. Chalo, let us talk about black body radiations. Let us see that black body radiations in detail. Right? Now, if you talk about the black body radiation, now I'll give you in a very simpler way, I'll tell you, right? Okay, like what you need to understand from black body radiations. See, have you seen any iron when we are heating an iron, right? What will happen? Firstly, it will turn from red to yellow, then to white, then the last stage will be blue. We know that what is happening here, red is having maximum lambda and minimum frequency, right? That means from minimum frequency to maximum frequency it is moving towards. That means, can I say the frequency is increasing? That is how it is changing the color. That is how it is changing the color. This I have written here as well. That is how it is changing the color. This is in reality what we can see from the experiment, that okay, when we heat any metal, any gray body, firstly though you need to understand what is this gray body, what is this black body. See, this experiment is basically on the gray body only, because as such black body does not exist. Okay, in reality black body does not exist. What is this black body? Black body, see, we know that whenever we talk about any thing, that will have three things. Whenever any electromagnetic radiation is falling on any particle, right, matter, first thing is absorption can happen. Second thing is reflection can happen. Third thing is transmission. Transmission can happen. Not transmission, reflection, refraction, absorption, this, and yes, refraction can happen. Now, here what will happen? Only absorption. For a black body, 100% absorption. That will happen. Now, in reality, there is nothing as such black body. In reality, we have gray bodies which has maximum amount of absorptions, right? Now, we are talking about one of the gray body, that is iron, right? So, it is having maximum absorption. You are giving it the energy. Because of that energy, because you are giving it heat, you are increasing the temperature. So, whenever you are increasing the temperature, what is happening here? The frequency is increasing. That is the reason the color is changing here, right? That is in reality, this thing is happening to the black body, right? But if we talk about the model, the Rutherford model, or the wave nature, not the Rutherford model, it was the wave nature. If we talk about the wave nature, now wave is a continuous thing. Wave is a continuous thing, right? It is continuous. It is not breaking into patterns, right? So now, if we are saying that this radiation is a continuous thing, there is continuous supply, or you can say continuous chain of frequency and lambda are there, then what should happen? But according to electromagnetic radiation, it is a wave. So, according to electromagnetic radiation, energy is directly proportional to intensity, and that is in square of the amplitude that I have taught you here, right? I have taught you here that in the wave, if we talk about the wave, intensity is directly proportional to amplitude square. The amount of light that we will get, it has no relation with the frequency, right? According to the electromagnetic radiation, according to the wave nature of this electromagnetic radiation, there is no relation, right, with the frequency. If frequency is increasing, there is no relation. The color should not change. But we have seen that the color is changing, right? But we have seen that the color is changing. But according to the electromagnetic wave nature, the color should not change because it should be independent of the frequency. So it should have the same color. But in reality, the color is changing that we are observing daily. That means the energy is gained and lost in the form of packets. And these packets are given by, there is also one graph, right? There is also one graph, as you can see here. This is lambda and this is intensity. What they have seen, this blue graph is your classical graph, right? This is your classical graph. This is your classical graph. And this one yellow graph is your real graph. This classical graph says that whenever you are decreasing the lambda, you are increasing the frequency. This intensity is increasing, right? We don't know what is the reason it is increasing. But in reality, what is happening, as you increase the lambda, right? Sorry, as you decrease the lambda, increase the frequency, it is going towards the maximum, then it is decreasing, right? So it was very, we were not able to understand these concepts here, right? That is why, firstly, the Planck will come here. Planck will say that this is real graph you can draw, right? Now that is not in your syllabus, right? That what is the equation given by Planck's, but you just need to understand one thing, that Planck was able to justify this real graph with his equation, right? That is not in your syllabus. That equation is not in your syllabus, right? So you don't need to get into that. Just remember that this was the classical, that was the real graph. Classical and real graphs were not matching with each other, but Planck's gave one equation, and in that equation, when we put different values of lambda and intensity, it was giving us this kind of graph. That means Planck is right here. And Planck was also saying one more thing, that is Planck's quantum theory. That is Planck's quantum theory, right? Because he was able to tell us that this is a real graph, he was able to justify this graph of black body radiation. That is the reason we were able to understand that, okay, if Planck is saying that the energy is existing in packets and that is in the form of h mu, he is saying that the energy is not continuous, as you are saying that if the energy is continuous, then it should be a wave. If it is a wave, the energy is continuous. If it is a wave, then energy should not be dependent on the frequency, it should be dependent on the intensity, right? So why the color is changing? For that, Planck said that, I will also give you the reason why, like Planck said that this is real graph, I will justify this graph also. But for that, you need to understand one thing, that energy is in the form of packets, because the justification that he gave, the equation that he gave, in that equation, the energy values were E is equals to h mu, right? Because of that, now we know that energy is actually existing in packets as well, right? Okay, that is existing in packets as well. So we can say energy is in the form of packets, and the packets of the light is called quanta. So that is why it is called as Planck's quantum theory. Okay, everybody, are you able to understand how we have Planck's in this vision now? Firstly, black body radiation, it had so many limitations, we were not able to understand that. So Planck solved that problem. That is why today we know that the equation that he gave us was based on this particular thing, that E is equals to h mu. What we have to take out from that Planck gave us this equation, that E is equals to h mu. Okay, he solved this graph also from that equation, right? Now, this is the second thing what they can ask you, right? I'll give you very simple answer, because this is mentioned in your NCERT. So I'll give you very simple answer for that. See, there were experiments going on. Now they were clear that this is the graph. Now they were increasing and decreasing the temperature. They are saying that on two temperatures, we are just drawing the intensity versus lambda graph here, right? What they observe that when you increase the temperature, see, this is your lambda 2 and this is your lambda 1. We know that definitely lambda 2 is less than lambda 1. When you increase the temperature, the lambda is decreasing. Can you see that? Here T2 is greater, that is why lambda 2 is less. That means that this maximum lambda, because at this point, which is having the peak of that graph, here this lambda is basically your lambda max at that temperature. That means, can I say that whenever I'm increasing the temperature, my lambda max is decreasing, right? My lambda max is increasing. So can we say that T and lambda max are inversely proportional to each other? They are inversely proportional to each other, right? Okay, can we say that lambda max is inversely proportional to T? Now, this is by Wien's law also, right? They will not ask you this, but just go through this, that he stated that lambda max and T are a constant, that is 2.9 10 raised per 3 meter Kelvin. This is the value that he gave. And from this, we know that lambda max and T are inversely proportional to each other. I would say that, okay, just go through this because this is mentioned in your NCERT, right? Now, here there is proper justification, right? What is the justification? Now we know that as temperature is increasing, right, frequency is increasing, that is why lambda is decreasing. Red to yellow, this was the last part. Now here we can say that as temperature is decreasing, right, I max, right, that means intensity, the maximum intensity at that lambda, right, it is high, right, it is high. But if you talk about when temperature is more, I max, that means maximum intensity on that lambda is low, right? Basically, you don't need to even understand this thing, just understand that lambda max is inversely proportional to T. When we decrease the temperature, the lambda max will increase. The intensity, the peak point of the intensity, that corresponding lambda will be low when you increase the temperature, and that lambda will be high when you decrease the temperature. Okay, right? Okay, thank you, quantum. Yes. Okay, guys. Okay. Sure. Understood now? Now let us go through the Planck statement, photoelectric effect also. We have done Bohr model. Let us see the Planck statement here as well. Right? Okay, where was Planck statement? Isobars, photoelectric, black body. I have seen Planck statement somewhere. Here. Okay, now let us see the Planck statement, right? Planck's quantum theory, he said that E is equals to h mu. We knew that mu is equals to c by lambda. So just put it here. This will become hc by lambda. We know that 1 by lambda, this 1 by lambda is nothing but it is wave number only. So it will become hc wave number, right? So these are the three values, right? For n number of, if we say n number of orbits, it will be n h mu, right? So it depends on what is the shell number, what is the orbit number, right? Now this is very important to solve the numericals. This thing that I have written here is for your numericals, okay? These things are for your numericals. Because they will not ask you the statements directly, they will ask you the numericals based on this, right? For numericals, you should know these things, that what is h? H is nothing but it is 6.6 Planck's constant, so it is 6.6 into 10 raised to power minus 34 joule second. What is h into c? C is the speed of light, so it will be 3 into 10 raised to power 8 meter per second. You just multiply this, you will get 20 into 10 raised to power 26 joule meter, okay? This is 26 joule meter, okay? You can just write here joule meter. This is joule meter, right? Then you have, let me use the same pen. This is joule meter, right? Then you have 1 electron volt, right? If they have, given you the options in electron volt, then you need to convert joule into electron volt. So you need to know the conversion as well. 1 electron volt is equals to 1.6 into 10 raised to power minus 19 joule. Okay, 1 electron volt is equals to 1.6 into 10 raised to power minus 19 joules, right? Okay, next is very, very important, very, very, very important. That is, if you want to calculate the energy in electron volts, The direct formula is, if you don't want to get into all of these things, direct formula is 1240 divided by lambda in a nanometer. If it is a nanometer and you want to calculate the energy in electron volt, this is the long process, this is the short process. If energy is given in electron volt, right? Or you can just put the lambda in Armstrong, it will be 12400 by lambda in Armstrong. Right? So this is a very, very important formula, right, for your numericals, right? Okay. Now next thing is that what he also said, that frequency is additive in nature, wave number is additive in nature, but lambda is not additive in nature, right? Because here you can get frequency. If you have this frequency, it is splitting up into two, mu1 and mu2, so these to be additive. If you have a lambda, it is splitting into lambda 1 and lambda 2, then lambda will not be equals to lambda 1 plus lambda 2. But if you have a wave number that is splitting into two parts, right, then this wave number and this other wave number will be added and you will get the original one, right? Okay, yes. Yes, Neha, I'll just hydrate myself, right? Okay, guys, is that clear or not? Everybody in the chat box, tell me. Because after this, we'll do the photoelectric effect, okay? Do the photoelectric effect here. Okay, guys. Okay. Now, let us see. Now, let us see the photoelectric effect. Right? Okay, guys. Let us see the photoelectric effect. So, I have taught you this with a very, very interesting story of you and your friend. Okay. So, you are sitting at home, your friend is having one birthday party, they are saying that, okay, this is my birthday party is happening. So, can you just come to this birthday party? You're like, okay, no, my parents will not agree to that. You're like, okay, why my parents are not agreeing to that? Now, your friend is like, okay, I'll convince your parents, right? Your friend is like, okay, don't worry, I'll convince your parents. Just wait for a second. Now, your parents are basically the metal here. This is the metal, this is your house, okay, this is your house. You are sitting here, you are in your house, you are sitting here in your house. Your friend is coming to your house, okay, he's like, okay, I will come to your house, and here what he will see when he will strike here, so basically the friend is nothing but this is the photon, this is the incident light. This is the incident light. This incident light will have an energy that we call h mu, right? Now, this metal surface, this surface will have the energy. Basically, everyone's parents have, like, they have some patience, or they have one, everyone's parents are different. Some are very lenient, some are strict, right? So, they have that one, you can say, peak point after which they are like, okay, now you are forcing me too much, then I can allow you, right? So it depends. Everyone has that brim, right? So now let us see this brim, this peak point of your parents is their like power of, how much energy it will get you to convince them, right? How much energy it will get you. But here, for this metal, how much energy we will use, right? That means this incident light will use to take this electron out of this metal will depend on the nature of this metal. If this nature of the metal is sodium, lithium, aluminium, all of them will have different power, right, of letting the electron go. Now, that thing is called the work function. That thing is called the work function, which is represented by h mu naught, right, which is represented by h mu naught, right, that is represented by h mu naught. Okay, okay. Who is this Instagram user? Stupid people on this earth. Stupid people. I don't know how they get so much time to come here. And I seriously don't know how can people be so unemployed in their life. Okay, so this is the work function. This is h mu naught. I to don't even get time to hate people. Yeah, I don't even get time to hate people who I actually don't like. Right? I don't have that time. Right? I don't know how they are having that time. NEET aspirants are not having time. JEE aspirants are not having time. Both students are not having any time. Teachers are not getting any free time. But these people are definitely totally free. That is why they are free, because they never studied. Right? So here you have h mu naught. This is the work function. This is the incident light. Now see one thing. This electron will be ejected out of this only if h mu is greater than h mu naught. Right? If h mu is not greater than h mu naught, right, in that case electron will not be ejected. Here electron will be ejected, right, and will be having a electron, will have kinetic energy as well. For example, incident light had 15 amount of energy, right, 12 amount energy you have used. We know that h mu is greater than h mu naught. This is the power of the parents. This is your incident light. Now we are still left with 3 units. This is basically your kinetic energy. That means we can say that h mu is equals to h mu naught plus kinetic energy. Right? That is why we can also say that if h mu is equals to h mu naught, in that case, electron is ejected but no kinetic energy. If you're like, you are able to convince the parents. They are not so happy. They are like, okay, if you really want to go, go. But they are not like, okay, take this gift for your friend, take this for your friend. No. But if your parents are very happy, they're like, oh my God, your friend is amazing. I to totally love your friend. Why you are not, you should also become like him or her, right? Then they are very happy, right? In that case, they will also give you money. They'll be like, okay, take this gift for that. Take one cake for your friend, right? Here they like, hardly we have given you permission. That's it. We are not going to give you any money, right? So if it is greater, electron is ejected with the kinetic energy. If it is less, electron is not ejected. If it is equal, then electron is ejected, but there is no kinetic energy that it will have. Right? Now, if we are putting one potential on it, if there is some external, some like clever friend out there, right? He is like, okay. For example, Chintu, Mintu and Bintu, right? Chintu and Mintu, right? Chintu came to Mintu's house. They are like, okay, able to convince Mintu's parents. Bintu is very jealous. Bintu is like, why Chintu and Mintu are going? So Bintu is that stopping potential. Bintu is like, I will not let them go. Bintu will come to Mintu's house and they will like, gossip about their party, this and that, right? So what will happen? So basically what Bintu is trying to do, he is trying to stop Chintu and Mintu, right? So here, this is called the stopping potential. So when you apply stopping potential here, the formula will become E into Vs. Vs is the stopping potential. Usually kinetic energy is equals to charge into Vs. Here we are talking about electron, that is why the charge I have taken it as E. So this will become the formula. Right? Is that thing clear to everybody or not? Is that clear? Is that clear, guys? Is that clear? Right? Okay. Now we are going to see the formulas in a different way, right? How they can be written in a different way, right? Okay. Sir is stop. Yeah, Baswa sir will like, okay, ma'am, mujhe kyun toda? Okay. Now photoelectric effect, right? Photoelectric effect, now I have told you that this is the formula, how and why, everything we have discussed. Now, some of the very important points we are going to discuss on which the question can be asked. Right, here we have written the formulas, and here I am going to explain you what is the reason for that. Right, what is the reason for that? Okay, now this though I have already told you. Now here you have Ke is equals to h mu minus mu naught. How come you have this thing? See, we have h mu is equals to h mu naught plus Ke. So if you take it here, Ke will become equals to h mu minus h mu naught. Take h common, it will be mu minus mu naught, and this is your kinetic energy. Right? So this is what I have written here. Right? Now after this, let's see, we know that mu is equals to c by lambda. Because I am just writing here different formulas that we have used. Mu is equals to c by lambda. That is why here we have put c by lambda. This is c by lambda naught. C we will take as common, this is hc, and this will become 1 by lambda minus 1 by lambda naught. We will take the LCM here, this will be mu naught minus, mu naught I am saying, lambda naught minus lambda divided by lambda naught into lambda. So this question also has been asked in your NEET. Okay, one more way you can write it here, Ke is equals to h c by lambda naught. C, take it as common, 1 by lambda minus 1 by lambda naught. We know that 1 by lambda is the wave number. So we can write it also in the form of wave number. K is equals to hc, right? This is 1 by, what is lambda? Wave bar minus V bar minus V bar naught. This also we can write in the form of wave number. Right? So these are the different ways in which you can write the formula. Okay? Understood? Now, next is the dependence here. Next is the dependence. Again, very important theoretical question can be asked from this particular chart. Okay, a theoretical question can be asked. So let us see what kind of theoretical question can be asked here. Okay, guys? So, dependence. So if you talk about the photons, right? So what we observed, this also we, if you want to see one of the session that I did with Shreya sir, that is the photoelectric effect, we also showed you in an experimental way how on increasing the energy, frequency, things are changing, electrons are moving. So if you want to see, just type photoelectric effect by Diksha ma'am and Shreya sir, Vedantu NEET English, you will get that. And that was really amazing. Students totally loved that, right? So now, this is h mu is equals to h mu naught plus kinetic energy. This we have done. Now, first dependence is on the photons. If you increase the intensity of the incident light, that means the number of photons we are increasing. So, if we increase the intensity or the number of photons we say are increasing, both are the same things, then number of electrons ejected will be increased. So, photon will, if you increase or decrease the photons, number of photons, then the number of electrons ejected will be increased or decreased. That are directly proportional. More is the number of photons, more electrons will be ejected. It's like more friends will come to your home, right? Okay, not to your home. If for example, 10 friends are coming to your house, right? But those 10 friends are not able to convince your parents, then what is the task? No. So, in that case, always mu should be here. All the things that we are discussing about here, mu should always be greater than mu naught. Only then this is possible, right? So, for one photon, there is one electron. You can see for one photon is able to eject only one electron, right? One photon is able to eject only one electron, right? That is why more the electrons ejected, more will be the current here, because current means the flow of electrons, right? So second is frequency of the incident light. So we know that if the frequency of the incident light, we have already seen it here, that if the frequency of the incident light is more, less or equal, different scenarios can happen. So if you want to eject the electrons with kinetic energy, then obviously frequency of the photon should be greater as compared to the work function. So frequency of photon is directly proportional to the kinetic energy. How? If frequency is greater than this, then you will have kinetic energy. If like it is like really more, like for example, frequency of the photon and you are getting the energy as 15, work function is 8, then you will get 7. 7 is the kinetic energy. Then frequency of the photon is now 20, but the work function is same. Now you are getting 12 as the kinetic energy. That means as the frequency of the photon is increasing, the kinetic energy is increasing here, right? Okay, so definitely we can write this thing here, right? Next is metals. Now this is directly from your NCERT table, so you should know this thing, that metals, the size is directly proportional to the work function. So what do I mean by that thing? That means if I talk about sodium and lithium, which is having more size, Lena, down the group size increases. Sodium is having more size. If you talk about the size of sodium is more. So can I say that this is my proton, then it is having more size here, right? It is having less size here, right? So can I say this is small, this is large. That is why the outermost electron will be more attracted. Here it will be less attracted. Here it will be more attracted. Because of the more interactions, it will be difficult for this electron to go, right? So if some kid is very connected to their parents, they are like, okay, my parents will say this, I'll do that thing only. If they are saying this thing, that is because maybe they think that this is not right to me, so I'll just obey them, right? So it means this is very attracted to the proton, right? Very attracted, very high attraction is there. That is why it is difficult. That is why the work function here is very high, right? Okay, so work function is high here. Okay, opposite I have written here, more the size, less is the work function. Wait a minute, let me just correct it here. More the size, less is the work function. More the size, less is the work function. Work function. Okay. Understood everybody? Understood? Hello Meenakshi. Hello Ram. Hello Sneha. Sneha also there only. Ma'am attended that session. Very good. Very good. Hello Emperor. Yes. Everyone is fine. Your Forger. You tell us. How very unique name you come up with. Hiding your identity. Okay. Now, next is photoelectric effect also we have done. Now, we have Bohr's model. Oof, Bohr's model. So, after Bohr model, we will take break, right? Okay. Chalo. Now, let us talk about the Bohr's model. Okay. Yes, everybody. Hidden talent. Keep it hidden. Okay. Ma'am, it's a character in anime. Okay. I don't watch it. Okay, you guys are going to increase my knowledge here. Okay, at least a teacher never gets old. Reason, because a teacher is always connected to the new generations, right? So a teacher is always getting updated on new things, isn't it? Yes, always. So there are so many things that my friends don't know, but I know those slangs. Why? Because I'm teaching you guys. Okay, now let us see the Bohr's model. Everybody ready? If you guys are ready, then green hearts in the chat box. Green hearts, okay? Don't be confused. Okay, when it comes to green hearts, just shower green hearts like this. Okay? Yes. Vedantu ji will take GOC. I'll take GOC soon. Don't worry about that soon. Don't worry about that. Yes. Okay, I want to see that energy in the chat box. I want to see that energy in the chat box. Everybody. Not now, Ram. I am trying to learn, but I am, still, because, learning languages is a tough task. But I'm still trying to learn some words. Yes, okay. Always in for new things. Okay. Now, we have Bohr model on your screen. After Rutherford, we know that very good. After Rutherford, this series will be this batch will be completed in Feb. Yes, Feb it will be completed. Huh. Okay. Now, very good, Swati, very near to me. Now, Bohr's model, let us see Bohr's model. Basically, what is Bohr's model? Now, he is going to tell us that if you talk about these protons, he is saying that the electrons are moving in discrete orbits, right? He's also saying the same thing, that it is moving in circular orbits, but he's saying that these circular orbits are discrete. They are at specific distance from the nucleus. For example, this is n is equals to 1, right? This is at a specific distance. And this n is equals to 1 is having specific energy, 2 is having specific energy, 3 is having specific energy. They are having different energies, right? Now, he is saying that electron, for example, you are going to your relative's house, right? You are like, I will wake up at 12 p.m. But your relatives everywhere, everyone wakes up at around 8 a.m., right? Then I think with that guilt only, with that embarrassment only, you will wake up at 8 or 9, maximum 9 or 10. You'll be like, okay, what everyone think about me. That means we human beings, we mold ourselves, right, in the situation where we are, right? So the same is for this electron. If electron is in n is equals to 1, it will have that energy. If it is in n is equals to 2, it will have the energy of this orbit. If it is in n is equals to 3, it is in this orbit. So basically, electron does not have energy of its own. It has the energy of the orbit in which it is residing, right? So here, now to tell me one thing. If you want to go from one place to another, right, you have to give money, right? You have to book an Uber, Ola, you have to book a cab, anything, you have to book an auto, anything, right? You have to give money. So in the same way, if it is going to go from n is equals to 1 to 2, from lower to higher, we know that here energy will be low, here energy will be high. So fun thing, so you need to know that as n increases, energy will increase, right? Now, if it is going in higher energy region, right? Now here, for example, here you are living in that PG, right? In that PG, where they are charging you maybe 1,000 rupees. Here they are charging you 1,000 rupees, right? Here they are charging you 2,000 rupees. Here they are charging you 3,000 rupees. Now, when you want to move from this situation, n is equals to 1 to 2, that means you will have to get more 1,000 rupees here, right? You will have to gain more energy. Only then you can jump from this to this. If you want to jump from second to first, then here you have 2,000, here you have 1,000. So you will not be like, now, okay, I used to give 2,000 before, take 2,000. You will be like, psycho or what, right? I am asking 1,000 rupees from you. Why are you giving me 2,000 rupees? Do you have that much money, right? So here, when it is going from 2 to 1, definitely it will lose that 1,000 rupees. It will lose that much amount of energy which it does not require, because for here to live here, it only needs 1,000 rupees. Okay, so that means on going from one position to the other, on going from, wait a minute, yes, on going from one position to the other, right, one orbit to the other, it will have to radiate the energy. That means have to lose or gain the energy. When we talk about when it is going from lower orbit to higher, right? Lower orbit, I'll just write it here. When it is going from lower orbit to higher, right? Lower orbit to higher, then it will gain the energy, right? It will gain energy, right? If it is going from higher orbit to lower, then it will lose the energy. And guys, from Bohr model, they ask the maximum amount of question. Mostly you will see the question from Bohr atomic model in your exam, right? Okay, that too very simple. I am very Bohr today. You guys are talented. Okay, now this is valid only for one electron, right? That means it is only for hydrogen atom. It is only valid for hydrogen atom or hydrogen like atom. You can say hydrogen atom or hydrogen like atoms. That means if helium lose 2 electrons, it is valid for not 1 electron. That means whenever an atom has 1 electron, it is only valid for that particular atom, right? Okay. So now next is electron has energy of orbit in which it is residing. It will lose or gain energy in the transition from one to another. Now next thing is this postulate and this postulate. In this postulate, it is saying that electrostatic energy, because see, the question in Rutherford model was how it is able to balance each other. So, centripetal energy. First thing is, we know that electrostatic energy here is equals to the centripetal energy, right? Centripetal energy, whenever something is going in a circle, right, it will try to balance on this basis. So there are some circles on also. When you go to any circles now, there is, I think, some motorcycle stunt is there. I don't know if today it happens or not, but when I was a kid, I used to see all these things on TV, right? Some motorbike, it will just go like in a circle, right? So how the motorbike person will be able to balance that motorcycle? Because of the centripetal force. Even if you have a thread, you have a thread and you just make a knot with some stone and try to rotate it in a circular motion, right? What will happen? It will balance itself, right? How? Because of the centripetal force, right? So that is basically the concept of physics. So centripetal force is mv square by r. And what is electrostatic force? Electrostatic force is kq1 q2 by r square, right? What is q1? q1 is your proton here, right? Number of proton is z. E is the charge on proton, and we are talking about that electron and this charge. The interaction is between the electron may be here and this proton. The electron may be here and this proton, right? So that one electron and the proton. So proton is having plus Ze and electron is having minus E. Just multiply this, you will get this. Now I will not do the derivations here. Reason being they are not important for you, right? So from this particular equation and this equation. Now this is a very, very important postulate that says that angular momentum, right? This mvr is nothing but it is the angular momentum. This is angular momentum. Okay, this is angular momentum. Now, angular momentum is equals to nh by 2 pi. Right? Also, you can write one more thing. H by 2 pi is equals to h cut. Right? So, this mvr is equals to nh by 2 pi. That means angular momentum is integral multiple of h by 2 pi, where n can be 1, 2, 3 and so on, right? N can be any integer here, right? Okay, so that is a very, very important postulate. Because of these postulates, we will get different values of radius and not different values. We will get a formula for velocity and radius in combining these two equations, right? I am not going to do the derivations here. I'll just give you the formulas here. Just take a screenshot of this one, right? Okay, just take a screenshot here. I'll also provide you the PPT, the notes here, but just take the screenshot, okay? Very good. NH by 2 pi. Very good. 6.28. Very good. He is also given the value of 2 pi. Very good. Okay. Now, formula of Bohr model. Right. So, what are the formulas? First is radius. So, the formula of radius is 0.529 n square by z, or you should also learn this radius is. If you know this formula, then you don't need to learn this. Right. Because sometimes they give you the comparison questions that for R1, the value of n is 2, right, is the same atom. R2 is, when it is n is 4, it's the same atoms. What is the ratio of R1 by R2? R1 by R2 is 4 by, this is 1 by 2 square, so it will be 1 by 4. Right, these kind of questions can be asked. Understood how these questions can be asked? Based on the comparison, that if you have radius of second orbit and radius of fourth orbit, the ratio of radius of second and fourth orbit for the same atom, right? The ratio of second and fourth orbit for the same atom. If the orbit is 2, so n will be 2, it will be 2 square by z. If orbit is 4, it will be 4 square by z. Z will cancel each other, and R1 by R2 will become 1 by 2 square, that is 1 by 4. Right? So that is why I am saying not only the formula, this also you need to understand that they can also give you the comparison questions here. Okay? Understood? Now next is Rn. If you want to write it in the form of angstrom, it will be 0.529, or you can say 0.53. In the picometer, it is 52.9, right? Okay, understood. Either learn any of this, you already know the conversions, right? Then for velocity, they will ask you in meter per second only. Radius, they can ask you in different units, right? So they will, here the most chances are they will ask you in meter per second only, otherwise so you can change it, right? So this is 2.18 into 10 raised to power 6 z by n, right? So this thing has reversed, it is proportional to z by n. Time period, it is proportional to, we know that what is speed is equals to distance by time. So time is equals to distance by speed. What is speed? Speed is the velocity, that is Vn. What is distance? Distance is, we know that atom is a circle. Atom not a circle, atom is a sphere, right? So the sphere will have what kind of, you talk about the orbits here, right? The circumference of that orbit will be 2 pi r. Right, so it will be 2 pi r is the radius. So you just need to put the values of r and v here, and what we will get here, the formula is not important, formula of v is important, formula of r is important, whatever I have written basically on this page is important, radius and velocity formula is important, energy formula is important. For time period, you just need to know what is, how it is directly, how it is related to n and z. So time is related to n and z by n cube by z square. Okay, n cube by z square. Right? Okay. Then you have energy. Energy is minus 13.6 z square by n square electron volt. Right? Minus 13.6 z square by n square electron volt. If they ask you in joules, z square by n square is same only. Right, this is minus 2.18 into 10 raised to power minus 18, right? Okay, and this is negative, right? This is negative, right? Now, this is the formula for total energy. If they ask you the potential energy, they ask you the kinetic energy, then see, this is a simple thing that I have written here, a very simple way to learn. Okay. If you ask me, do I need to remember this formula? I would suggest you don't need to cram this formula. You don't need to cram these three formulas, right? But you need to know this formula and this thing, right? If your potential energy is minus x, then just talk about if your kinetic energy is plus, then potential and total will be negative of that, right? Now, if this is minus x, kinetic and potential, sorry, just remember that this, potential energy is minus x, then kinetic and total energy are half of the potential energies. But kinetic energy, the sign will also change. For total energy, the sign will remain same as potential energy. Okay. If I say 5 is my, if I say 10 is my potential energy. So, for total and kinetic, it will be 10 by 2, 10 by 2. But for total, the sign will remain same. If this is positive, this will also be positive. But kinetic sign will remain opposite to that. Right? Okay. So, mostly this potential will be negative. Mostly you will see like this only. Right? Okay. Actually, yes, you need to cram these formulas, guys. I'm so sorry about it. But yes, you need to cram these formulas. That's not in my hand, but you have to. Right? Okay, otherwise, so it's not possible. There is no trick in this. You just need to copy, paste this somewhere, right? In your, like, that's why these formulas. But the best part about this chapter is that it is easy to apply the formulas. The question will be very direct. The question will not be complicated. The question is direct question will be asked, right? So easy questions will be asked from this one, not complicated questions. But learning the formulas is a task here, right? So that is a tough task that you need to do, right? Okay, so I would advise you to just paste the, because it has a lot of formulas, right? Even now we will go to hydrogen spectra also. So when we will study hydrogen spectra, more formulas will be added here, right? Okay. Yes, everybody. Now ionization energy. So see, ionization energy means to take out the electron. That is opposite of the total energy. So here it is negative, here it is positive, here it is negative, here it is positive. Everything else is same. Okay? Everything else is same. Basically, you have these two formulas to remember. Then you have this formula to remember. These two formulas of energy. Ionization is opposite of that, sign is opposite, and for total kinetic and potential, this is thing that you need to remember, right? Okay. Okay. Yes. Now, but if you are focusing on NEET, automatically your board is getting taken care of, right? Yes. Now, hydrogen atom, right? Hydrogen atom, and for boards, was the one who was asking the question deleted it or what? Huh. For those students who are focusing on boards, right? So we have our KCT Karnataka channel. From there, we are starting the series where we are only focusing on the boards questions, how they are asked. So daily it will be 1 hour live for that. So if you go through that live, I think your board preparation is also you are doing in that just 1 hour, because we will take out the best questions there, right? So automatically focus on NEET as well as board as well as, but see the board question on that channel, just 1 hour daily, right? Now here you have hydrogen atom, right? You have hydrogen atom. Yes, what is the doubt? Let us talk about hydrogen atom here. Let us talk about hydrogen atoms. Everybody. Let us talk about hydrogen atom. Okay. Now, firstly, though, if you put the value, see for hydrogen, what is the value of Z? Everybody. For hydrogen, Z is equals to 1, obviously, right? Because atomic number is 1. So if your Z is equals to 1, then just put the value of N is equals to 1 here, it will be minus 13.6. Put the N value as 2, it will be minus 13.6 divided by 4, it will be minus 3.4. Put N is equals to 3, it will be minus 13.6 divided by 3 into 3, 9. Okay, that will be minus 1.5. So what you can observe here, is the energy decreasing or increasing? First, there is one confusion related to that, especially to NEET aspirants. They're like, ma'am, we are like, how energy is increasing, decreasing? Huh? If you talk about the number line, this is minus 13.6. This is minus 3.4. So definitely you are moving towards the 0. So the energy is increasing here. Just don't see the digits here, ma'am, it is decreasing. Energy is increasing here. Okay, energy is increasing. So as n is increasing, energy is increasing. At n is equals to infinity, just give me a second, yes. At n is equals to infinity, energy will be equals to 0. That means if we talk about infinite orbit, at that point there is 0 energy, right? Okay, right. Now these are few things that you need to understand. Okay, so first thing is for Lyman series. So Lyman, there are 5 series: Lyman, Balmer, Paschen, bracket, Pfund. Ma'am, do I need to remember this? Yes, because question has been asked from this particular chart as well, and it is a like frequently asked topic, right? Okay, it is a frequently asked topic. So Lyman, N1 and N2 we are talking about. Here, basically, let me see if we have that. Okay, I don't have that diagram, so I'll have to draw it myself. So guys, just give me a second. This is my n is equals to 1. This is energy. It is definitely increasing. Now tell me one thing. The gap is increasing or decreasing? Here the gap is of around 10 units. Here the gap is of 2 units. Here the gap is even less. Here the gap is just few points. So that means the gap in the energy, the delta E, this minus this, it is decreasing or increasing as we increase n. Delta E is decreasing. It means gap is decreasing. As we increase the n, the gap is decreasing. So that is why when we draw the diagram, we will decrease the gap here. Okay, the gap will decrease here. The gap will decrease here. It will be even less than that. Wait a second. It will be even less than that, right? Then you have this is equals to, wait a minute, this much only, right? Okay, and so on, it will decrease, right? Are you able to see this or not, guys? Are you able to see this? Everybody here, right? Okay, are you able to see this, everyone? No increase, not decreasing. No, it is decreasing. That's why it is decreasing. This is minus 13.6. This is minus 3 wait a minute, that was minus 3.4, right? This is minus 1.5, right? It is decreasing, okay? It is decreasing. Gap is decreasing. We are talking about the energy gap here, right? This is n is equals to 1. This is n is equals to 1, 2, 3, 4 and so on up to infinity. Talk about this one. This is so many energy states in between. So many energy states in between, right? And this I am talking about at n is equals to infinity, where energy is equals to 0. Now, what will be Lyman series? What is Balmer? What is Paschen? See, in Lyman series, n is equals to n1 is equals to 1. That means wherever it is coming, it is 1 only. So whether it is coming from 2, whether it is coming from 3, whether it is coming from 4, whether it is coming from 5, whether it is coming from 6 or coming from infinity, if it is coming to the n is equals to 1, then that is called Lyman series. Now, what is Balmer? What is Balmer? If it is coming down to n is equals to 2, from any state, from this state, from this state, wait a minute, yes, from this state, 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 that is your Balmer, right? If it is coming down to n is equals to 3, from this state or this state or this state or this state. So according to that, we have mentioned the names here. The names are Lyman, Balmer, Paschen, bracket, Pfund. Here n, it is coming down to n is equals to 1, it is 2, 3, 4, 5, right? N2 can be anything. It can be 1, it is coming to 1 now. Why I have not written here 1? if I want that this line should come back to n is equals to 2, can it go from this to this? No, right? Here so it is, that means it is moving up, it is not going down, right? So that is the reason that is not applicable here. So that is why n2 is greater than the n1 up to infinity, right? Greater than m1 up to infinity, right? Okay, understood. Understood. Now next thing is the ranges. Okay, Black, firstly tell me one thing. Are you watching this lecture for the very first time in your entire life? Now, Lyman is UV, Balmer falls to visible, Paschen, Bracken, P-Fund, they are in the infrared region. Okay, Black, don't spam here. Okay, if you are watching this lecture for the very first time in your entire life, you are thinking that other people are stupid who have actually watched around 10 to 15, like, like I think 6 months before I had done this lecture, right? They have done a lot of like practice also for boards also, they have watched the lecture, right? I don't think so. If only if you're completely blank on this, then so I can understand that how you're not able to understand. If you're not blank, then I am sorry for that. Okay, now total number of spectral lines. See guys, one thing to understand here, up to infinity, I don't know how many spectral lines can it form, right? I'd have no idea on that, how many, I'll have to see that one by one. Either so I'll sit in the exam hall, I'll be like, okay, 1, 2, 3, 4, 5, 6, then I'll count everything. Now, from 10 to 1, it will be very difficult to count the number of spectral lines, right? From 12 to 2, it is very difficult, right? So that is the reason, to make it easy for you to count the total number of spectral lines. What you have to do, n2 minus n1 multiplied by n2 minus n1 plus 1 divided by 2. That is the total number of spectral lines. For example, they are asking you from 4 to 2, how many spectral lines? So n2 is 4 minus 2. This is 4 minus 2 plus 1 divided by 2. This will become 2, and this is 2 plus 1, 3. 2 will cancel. 3 spectral lines we will have. If you see this diagram, for 4 to 2, how many spectral lines? 4 to 2 means you will have firstly this line, right? What else you will have from 4 to 2? This line and this line, right? So you will have total 3 lines between 4 and 2. This line and this line. So total number of spectral lines you can easily see here, right? So instead of drawing these lines, you just need to understand the formula here, that is n2 minus n1, right, multiplied by n2 minus n1 plus 1 divided by 2. Now, it is a very, very important question. If they have asked you specifically number of spectral lines for specific orbit, they are saying that, see, 2 questions I am writing here. Number of spectral lines for n2 is equals to 4, 2 n1 is equals to 1. Or they are saying that n2 is equals to 4, 2 only n1 is equals to 1. So there are 2 questions like this. Okay. Here we will calculate total number of spectral lines by n2 minus n1, n2 minus n1 plus 1 divided by 2. Right, so it will be n2 is 4 minus 1. This is 4 minus 1 plus 1 divided by 2. It will be 3, 4 divided by 2. It will be 6 lines. Total number of lines will be 6. Total number of lines. But if I say directly to from n4 to n1, how many specific lines? Specific lines. Specific lines. Specific lines are the higher number n that they have given to specific thing that they have given. So higher is 4 and specific is 1 because they are talking about only N1, only to this one. So here you will have 3 lines. Okay, here you will have 3 lines that are moving only to specifically to N is equals to 1. Right? Okay. Okay. See, from here we know that this will be that line, this will be that line, this will be that line. Firstly, from 2 to 1, 3 to 1, 4 to 1. These are the specific lines that are going only to N is equals to 1. Right? So if specific is given to you, that you just need to calculate, how many lines are going from some upper, that I am talking about N2, to only N1. Or if they are talking about total number of spectral lines, mostly they will talk about total number of spectral lines only, right? But you have to see that what they are asking you. Okay? Understood? Now, next is the formula, as you can see here, and there is one more thing. This too I totally forgot. So guys, see one thing, there are some of the terms that are mentioned here. First term is first line or alpha line or minimum energy or minimum frequency or maximum wavelength, because energy and frequency are directly proportional, but energy is inversely proportional to the wavelength. They can say that alpha line or first line, minimum energy, minimum frequency, maximum wavelength. If any of this is mentioned, that means they are saying that N2 is equals to N1 plus 1, right? That means N2 is equals to N1 plus 1. If they are giving you last limiting line or maximum energy, maximum frequency or minimum wavelength, or they can also give you short wavelength. Here they can give you long wavelength. Right? So if they have given you short wavelength, minimum wavelength, maximum frequency, maximum energy, limiting lines, last line, then this will be from infinity to N1, right? They will not mention N2 here. They will give you hint of N2. They will not mention N2 as 2, 3, 4. They will give you these kind of hints. If they have mentioned second line, so first line is N1 plus 1, second line is N1 plus 2, third line is N1 plus 3, fourth line is N1 plus 4, right? Like that it is given to you, then you will just add that number to the N1. Third line N1 plus 3, second line N1 plus 2, first line that is N1 plus 1. Last line is infinity, right? Okay. Okay, everybody. Now let us see where you are going to apply this particular formula. You are going to apply this formula here. N2 to N1, it is going. See, N1 can be given in this particular way, that they can give you, this is Lyman, Balmer, Paston, bracket, Pfund series. You will get a hint what is the N1. N1 will be given like this. N2 will be, either they will give you directly that it is 4, it is 5, it is 6, it is 7, whatever. Or they will give you in this way. Or they will give you in this way. Okay? Or they will give you in this way. Or they will give you first line, second line, third line, last line, limiting line, anything, hint for N2. Right? Now, N1, N2 you will know. Rydberg constant. What is the value of Rydberg constant? See, very simple thing. If they are asking you the value of 1 by lambda, then put 1 by RH is equals to N12 angstrom. Because see, you have to calculate the value of lambda here. If in the question they are asking the value of lambda, that means eventually even if you put the value of 109677, you have to reciprocate this thing and then get the value of 1 by 109677. Why to get into so many calculations? So there is an easy trick for that. That is, if they ask you lambda, just put the value of 1 by r, just reciprocate this thing and put 1 by r as 912 angstrom. You will get lambda in the angstrom, right? The units will be angstrom. If they ask you wave number, because this 1 by lambda is nothing but it is wave number only, then put the value of RH. Then put the value of RH as 109677 centimeter. Here you will get lambda in centimeter. Right? Here you will get lambda in centimeter. Okay. That 1 by lambda is equals to wave number? Yes. 1 by lambda is equals to the wave number. Right? Okay. Okay. Yes. Now, understood this or not, everybody? Understood this or not, everybody? Yes. Emperor is saying an average chemistry stream on this channel lasts for 4 hours. Oh my god. I would take it as a compliment. Okay. Yes, okay, understood this thing, that this is lambda, wave number, how to put the values. This you will get from the atom. What atom is given to you? If they have given you hydrogen, Z is 1, lithium, Z is 3, helium, Z is 2. So depending upon the atom, you will have the Z. Okay, so I will also do the questions based on this. Okay, don't worry about that. As Emperor is saying that average live streaming is like long only. Why? Because I take everything on in one lecture. I don't like to skip anything. I have that belief that okay, some student is watching my lecture, he should be able to get something out of that. Right? Okay. So that's it. Now let us see the failure of Bohr model. First is splitting of spectral lines. He was not able to explain Zeeman and Stark effect. He was not able to explain that why splitting of spectral lines, right, in the spectra, the spectral lines are getting splitted. He was not able to explain the reason behind that. Electric, now this question is your NEET question only. The splitting of electric field is called Stark effect. The splitting of, not electric field, the splitting of spectral lines in the presence of electric field is called Stark effect. In the presence of magnetic field is called Zeeman's effect. Okay, yes. Now, second is not valid for multi-electron. That is the drawback only, because it is only valid for hydrogen-like species and hydrogen. Right. Third is doublets and triplets. So whenever we make spectras, when you will ever study the spectras, basically this is one peak. So what we observe in NMR spectroscopy, sometimes it come like this. Okay, so this is two peaks. In one peak you have doublet. Triplet is that in one peak only you have three peaks here. Right, so this is called triplet. So he was not able to explain the triplets and doublets here, why it is so, why it is happening, right? Then chemical bonds, he was not able to explain that why, if atoms are stable only, they are happy, they are revolving around the electron, around the nucleus, then why they are losing and gaining electron and making chemical bonds? What is the need for that if atom is stable, right? Okay. Okay. Okay, guys. After this only we will do Schrodinger wave equation only. Yes, after this de Broglie hypothesis, as you can see here. After 2 slides, I will start with that. But before that, let's take break, okay? Before that, let's take break. Okay, guys? Everybody, shall we take break? Oi hoy. Shall we take break? Yes. Okay, lambda, okay. No, don't worry. He was not speaking anything rubbish. He was just talking normally. Okay, chalo. Okay then, guys, after I'll see you all after the break. But I want all of you to share this session on your WhatsApp status right now. Okay, in this break, I want all of you to share this on your WhatsApp status. Guys, before the session, only share this on your, share all the sessions on your WhatsApp. Right? Okay. Yes, chalo. So we have 8:40. So let's take break for 20 minutes. Himanshu, I am not on steroids. Even I am not on drugs. Okay. So I need to have energy. I am a normal human being, right? Which needs also, I also need break. You are also not on drugs that you can just use your brain for such a long time. We all need break, right? Okay. So I'll see you at 9 p.m. Okay. At 9 p.m. I'll see you all. After this, we are going to do quantum theory, Schrodinger wave equation. eigenfunctions and nodes, antinodes, all of these things, electronic configuration, and we are going to do previous year questions. Okay? Okay? Yes. Yes. Okay? Okay. Chalo. Yes, I'll message you guys on Telegram that the break is over. Okay? Yes. Hello, hello. Okay, so yes, everyone, I am back. I am back. Everybody in the chat box, am I visible? Am I audible to all of you or not? Yes, everybody in the chat box, am I visible and am I audible to all of you or not? Let me know in the chat box so that we can resume this session and start with the quantum theory, right? Start with the quantum model here. Okay? Yes, everybody, are you all ready for that? So we have completed till Bohr's model. Now let us move towards the quantum theory, right? Let us see what we are going to study here. So first thing is, there are so many other things that happened here, like de Broglie's hypothesis. So in this, he basically talked about the duality. He talked about the dual nature of electromagnetic radiation. Now, as you can see here, he has covered two things here. Momentum is in the classical model, right? Or you can say momentum is in the particle nature. Momentum tells us the particle nature, but lambda tells us the wave nature. So he has combined these two things and given us a new formula, that is de Broglie's wavelength. That is lambda is equals to h by p. P is what? Momentum, that is mv. And we know that mv is also called as, or we can also write 2mke here. Why? Because what is ke? Ke is nothing but half mv square. So it will be 2 will cancel out. It will be m square v square. It will be mv only. So 2mk is nothing but mv only. That is why instead of mv, in terms of kinetic energy, we can write 2mke. And I also told you one thing, that kinetic energy is equals to charge into stopping potential, right? If we are talking about electrons, so it will be EVS, right? So here it will be Q into Vs. If we're talking about electron, so it will be EVS, right? Okay, okay, yes. Now, next is for nth orbit, right? So this we are talking about de Broglie's hypothesis. Now, from this, can we say, from this, can we say that the circumference, now guys, for this we need to know one thing, that he basically told that this is the particle nature, this is the discrete orbit according to the particle nature. Okay, this is a discrete orbit according to the particle nature. And because we are talking about the duality, it is also existing as a wave, right? So he is saying that this circumference, that is 2 pi r is the radius of that orbit, right? This 2 pi r, I will just write it as rn because we are talking about radius of that orbit, is equals to n pi, right? It is equals to, why he is saying that for nth orbit, this 2 pi r, this we know from the particle nature, that this is the circumference. This is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, how many? N number of waves that you are forming. He is saying that the number of that orbit will be the number of the waves that you will have. So it will be n into wavelength. This is what he told you, that circumference is equals to n into lambda, right? Okay, understood this thing, that why I have drawn this diagram. Usually we only know that this is the formula, but we have no idea that what is this. This is the particle and wave nature together. This is the duality. This is mentioning the duality, right? From this, tell me one thing. What is lambda? Lambda is h by mv. So I have written h by mv. H by mv. Take mv here. Take 2 pi r, 2 pi here. So it will be mvr is equals to nh by 2 pi. Have you seen this equation anywhere? Yes. This is the third postulate of Bohr model, that angular momentum is integral multiple of h by 2 pi. That means this de Broglie hypothesis, which is talking about the duality, he is taking particle and wave nature both and giving you the equation so that we can also prove the Bohr model result, right? Okay, and it's a very, that's why this particular postulate is very important, because it is also followed by the de Broglie equation, right? Now, next one is Heisenberg uncertainty principle. For microscopic, that means it is only valid to electrons, protons. If I talk about myself, I am moving. Can you identify my position at one point? Yes. Can you know my speed? Yes. Okay, this is what we study in physics. We can identify the speed and we can identify the position at one point. Yes, at one instant we can identify these two things, right? But when we talk about microscopic particles, microscopic objects, it is not possible. That is called Heisenberg uncertainty principle, that the position and the momentum or the velocity cannot be identified at simultaneously. We can identify these two things. Either we will know the position or we will know the velocity. Two things we cannot define simultaneously, right? Okay, exact values we cannot define. That is why this is the relation delta x multiplied by delta p is greater than equals to h by 4 pi, right? Or this is also termed as h cut by 2. Because what is h by 4 pi, that h by 2 pi, that is h cut only, no? So it will be h cut by 2, right? So this we also can write it as mp delta v, and this is also in the terms of energy and time. It is written as delta E dot delta t. Derivation is not important for you, just remember the result here, right? Okay, understood? Now let us see now quantum mechanical model. So now guys, this is just, it's like it's an ocean, it's just one drop that I am teaching you of quantum theory. Even it is said that the quantum theorists who are working on this are themselves not able to understand the full quantum theory, right? So we are moving towards that, right? Ma'am had dinner, ma'am will have dinner after the class. So, quantum mechanical model. So, but don't get any motivation from me that okay, ma'am is having dinner, ma'am is starving. No, I'm not starving, guys. According to my routine, I had my proper diet, right? I had really good protein, like some paneer, right? I had it. So don't worry. Take motivation that I eat good, right? So according to my class, I'll eat dinner after. So you should also buy this. What you can learn from this thing, that you should also have some snacking, good healthy snacks you can have. So that you can, that why, how I am energetic even now, right? Because I had like little amount of like something to energize myself, right? So you should also have good water bottle. You should also carry some good snacks. Okay, good snacks doesn't mean fries, French fries, ma'am, burger, ma'am. No. Good snacks means either some healthy nuts or something you can have, right? Okay, that is my advice to you. Free ka gyan, right? Free advice I always give you. Okay, so now this is quantum mechanical model. I'll tell you what is this quantum. There are two models. One is classical, one is quantum. Quantum will work towards something which is probability, something, very imaginary things that will become real, right? So it is very, don't get too deep dive into this topic. I'll tell you what is important for you. So first thing is quantum model. It is going to deal with the probability of finding the electron, not the exact position. It is going to say maybe it is here, maybe it is here, maybe it is here. These are the different positions where the electron we can find. Now, it was this Schrodinger wave equation. You should know this equation. It is, this psi is basically, if you talk about what is this E here, E is the energy. E is the energy. This is the potential. This is the potential energy. This is the psi is the wave function. SI psi. This is psi. This is the wave function. Wave function, right? Okay, this psi square, right? That is the probability of finding the electron, or you can say probability density of finding the electron, right? Probability density of finding the electron, and this is your probability of finding electron, right? So if you talk about all these things here, yes. Okay, now this psi wave function, now you don't need to understand that how to solve this equation, ma'am, what to learn this equation. Just remember this is the equation, right? I have solved it myself, but still I am not able to understand what I solved, right? So it was there in our not MSc, it was there in BSc, right? So there was this proper quantum physics and quantum chemistry that we studied, and trust me guys, it is very difficult. It is very difficult, right? The derivation used to be 7-8 pages long, and I was not able to understand anything there, but like, it was the more I was able to understand, the more I was getting confused, right? So basically, when you are doing the derivation, it's not a thing that, okay, that's it, this is how it is done. It's like, this can happen, this can happen, this can happen, this probabilities we are talking about. That is why you have to go into an imaginary world, that, okay, this will happen, all are the probabilities, right? So in physics and chemistry used to be different, right? But yes, the derivations were really long, like really long. Okay, so now let us see this thing here. Now this H is basically the Hamiltonian. What is important for you to know, that this is the wave function. On this we apply this operator, Hamiltonian operator. Like you have multiplication, addition, division, right? These are Hamiltonian operators, right? Different operators we have, right? Now this, out of this, when on this wave function you apply this operator, you will get energy here, right? Okay, so this is a eigenfunction. Now if they ask you, is this an eigenfunction? Yes, this is an eigenfunction. And what are eigenfunctions? Eigenfunctions are, for example, you are doing, the operator is not Hamiltonian. I am just giving you a very simple thing here, okay, how to simply learn this thing. Hamiltonian operator is not in your syllabus, right? You just understand this is d by dx. Differential, so you know, na, this is also operator only. For example, your wave function is x cube. When you apply this operator on this function, what you will get? You will get 3x square. Did you get the same function? You didn't get the same function. This is not eigen. This is not eigen. This is not eigen. What is eigen? When you will get the same function. So, for example, I have d by dx, and this is e raised to power 2x. What is the differential of e raised to power 2x? It will be e raised to power 2x, differentiation of 2x. This, guys, you have done this in physics, okay? E raised to power 2x. And what is the differentiation of 2x? It is 2. So answer is 2 into e raised to power 2x. That means this is your eigenfunction. This function is eigen. That means this function is eigen. How come this function is eigen? Right? This function is eigen because we are getting the same value in the answer also. Right? Okay. So when you get the same value in the answer, that is called the eigenfunction. So here, this psi is the eigenfunction because after applying Hamiltonian operator, you are getting the energy, right? And you are getting psi. Right, so this is a eigenfunction. I think that is clear to all of you, right? The most simple way I have taught you this thing, right? Okay, okay, guys, everybody. Now, let us see. Now, this is psi square dV is equals to 1. They are saying that psi square, if you write psi square dV in that volume, that will be equals to the unity. This is basically a equation that you need to, if you want to remember, you can, otherwise this is not important for you, right? Okay. Now, next let's jump to the important part here. Let us see, yes, same value eigenfunction. Now let us see what, ma'am, we are talking about quantum numbers, nodes. What exactly is this? So just learning things, but you're not able to understand what exactly is this. Just remember this thing. Like whenever I solve any quadratic equation, right, you used to get the values of x, isn't it? Whenever you solve in maths, whenever you solved quadratic equation, you used to get different values for that. So similarly, when we solve the Schrödinger wave equation, that is this equation, this is what I told you, that its derivation is very long. Still, if you say that, ma'am, derivation solution must be just like quadratic equation. No, guys, it was not like quadratic equation. It was like you have to cram the full derivation, because nothing was ki, okay, this will happen like this only. Everything, every step was unique, right? So you can just imagine that, like what big derivation it was. So this solving this equation is not in your syllabus, right? You don't need to do PhD here, right? So you just need to understand that when you solve this equation, you get different values. One is real, one is imaginary. Imaginary we will not talk about, right? We will talk about the real values. Real values are graphs and quantum numbers, right? Firstly, we will talk about graphs also, where we will talk about nodes, how to calculate the nodes, what are the rules to calculate nodes. Then the quantum number, n, l and m. Now one question can be asked to you. Spin quantum number is not a solution of Schrödinger wave equation. This question can be asked. Schrödinger wave equation, right? That this is not a, you can say that yes, principal quantum number is a solution, azimuthal is a solution, magnetic is a solution, but spin quantum number is not a solution of this Schrödinger wave equation, right? Okay, otherwise other three quantum numbers are the solution of Schrödinger wave equation only. So let us firstly talk about the solution, that is quantum numbers, right? Just give me a second. Okay. Now, if you talk about this thing here, first is principal quantum number. Now, this chart again is very important. From this point also, the questions are frequently asked. Frequently, the questions are asked, right? So, I'll just tell you, it's like you are visiting your friend and you're asking their, like, for example, you have, you have ordered something and the delivery boy wants to know your address. What you will tell them? You will firstly tell them what is your city name, what is your society name, what is the house number, and which room you are in. Obviously, which room you will not tell them, but here we are considering that you're telling them which room. Just imagine your friend is visiting you, right? So first you will tell them which city, which society, then which is your house number, and then you will tell them I am there in my drawing room, I am there in my bedroom, right? Okay, so this you will tell them, right? Now, if you talk about the principal quantum number that defines a city, okay? If you talk about an atom, that will tell you the same orbit or shell that Bohr was talking about, right? Okay, here we will name it as shell. Okay, it is also called as orbit, but here we will call it as mostly shell only, right? Now, here this, as n will increase, because n can be from 1 to infinity, it can have any value, right? Now, in this orbit, right, those circular orbits, this is the atom, these are the circular orbits, right? In these circular orbits, what you will have, as the value of n will increase, right? That means n is equals to 1, it is closer to the nucleus. N is equals to 4, it is away from the nucleus. That means the size of that atom is very large. Because as n is increasing, energy is also increasing. So n is telling you about the size and the energy, right? Then, number of these are the formulas that I will talk on later, right? Then azimuthal quantum number. That will tell you the subshell. Subshell means inside this orbit, in which subshell, that means you are living in a city, in what is your society. You can't say this is my city, that other person can identify your house. It's not possible, right? So if they are visiting you, you need to tell them which society. So this is the society. This is going to tell them the shape. This society can be 0 is S, 1 is P, 2 is D, F, 3 is F. We know that all these orbitals, this is called orbital, not orbital, all these subshells have different shapes, right? S is spherical in shape, we will also do that. P is a dumbbell shape, D is double dumbbell shape, F is what? Everybody. F is complicated shape, right? So depending upon that, we will get the shape of that subshell. What kind of shape? For example, in some society you have big houses. In society you have middle class houses. In some society they are very small houses. So depending upon, so when you even visit any flat, like the society which is having flats, so the same kind of flats will be everywhere, right? Okay. Understood na? Same kind of flats, the builder will have the same kind of flat, right? So here it will tell you the shape of that flat. Okay, what is the shape, what are the type of houses you will have there. Magnetic quantum number, more detail into it. Now you have known that this is S or P or D or F, but now what kind of P? Is it Px? Is it Py? Is it Pz? They'll tell you, okay, I live in this society. You're like, okay, this society, but what is your flat number? Which flat you are living in? They can't visit 300 flats in that society, knock in every flat and say, hello, is this my friend? No, this is not my friend, right? This will be expelled out of that society, right? So here magnetic quantum number will tell you the orientation, where your flat is located, the orientation. Is it on x-axis, y-axis, z-axis, where it is located? Px, py, pz, dx square minus y square, dz square, dxy, dy, dxy, dxy, dyz, dzx, right? Any of these things. Orientation it will tell you, which is the axis in which it is. Spin quantum number, that will tell you that once your friend is in your house, you're told, and this is my room number, right? I'm staying, like this is my room number means this is the room I am in. Your mummy is like, okay, he's in his bedroom, right? So your friend just came in your bedroom and he is like, okay, everything is messed up here, right? So either your room will be very clean or your room will be very messy, right? So that is your clockwise or anti-clockwise structure, the rotation of the electron, right? So that either can be plus or minus, plus half or minus half. This is not a solution. It will tell you the rotation of the electron, whether it is clockwise or it is anti-clockwise, right? Now, azimuthal, if you talk about principal quantum number, that will be from 1 to infinity. Azimuthal quantum number is from 0 to n minus 1, right? If my n is 3, then this will be 0 to 2. It can be 0, 1 or 2. We know that 3D will be, S means, 0 means S, P and this is D. We know that 3 as 3P and 3D will exist. Today though we know na that 3S, 3P, 3D, all of them exist. If I say that, let's talk about n is equals to 2. That means L is equals to 0 and 1. That means it is S or P. Do you know 2D does not exist? Why 2D does not exist? Because L is equals to 0 to n minus 1. That's why 2D will not exist, right? Okay, so like that you can calculate anything. From M is from minus L to plus L. If my L is 2, then M will be equals to minus 2 to plus 2. That means it is minus 2, minus 1, 0, plus 1, plus 2. Now we know that 2 means D. Do we know that D has 5 orbitals? D has 5 orbitals. Minus 2, minus 1, 0, plus 1, plus 2. Definitely it has 5 orbitals. Right? So these are the generalization that I have written here. Right? Okay. Understood everybody? Next is spin quantum number. That will be plus half or minus half. Right? Now let us see the formulas here. Formulas are number of subshells will be n. Number of orbitals, if they are asking you, they have given you inner shell, right? They have given you inner shell. If you need to calculate the number of subshells in a shell, that will be n. Number of orbitals will be n square. Number of electrons will be 2n square, because in one orbital you will have 2 electrons. Now, this is in a subshell. In a subshell. In a subshell, they are asking you the number of subshell, not possible, right? Because we are talking about one subshell. Number of orbitals will be 2l plus 1. This is, we are talking about one subshell, not shell. For maximum electron, it will be 2 into 2l plus 1, that is 4l plus 2, because electrons will be double of the orbital. So, what you need to remember, firstly, is this particular, this formula is very important, then this formula is very important, right? These two formulas are must to remember, right? Okay, okay guys, yes. Now, next one is angular orbital momentum, that is under root L plus 1 h by 2 pi. Angular spin momentum is under root S plus 1 h by 2 pi. Okay, yes. RSK please, I think emission and absorption we are left with, I'll do that in the end, there is nothing very simple, right? Line spectra we have done, right? Okay, now let's talk about three principles which we will obey to understand the electronic configurations, right? So N plus L rule, that is N plus L rules of Bohr principle. That means if you want to know the, see, electrons will be filled according to the increasing energy orbit, increasing energy of the orbitals, right? So to know the energy of the orbitals, what will be applied? N plus L rule. That means more is the value of N plus L, more will be the energy. If N plus L is same, then more is the N, more is the energy. So if you want to say 4s and 3d, which has more energy and which will be filled first. So it is N plus L is 4 plus 0, that is 4. Here it is 3 plus 2, that is 5. So here N plus L is less, that is why this will be filled before and this will be filled after. That is why 4s is less in energy as compared to 3d. That is why we fill 4s first and after that we will fill 3d. Okay, that is the reason. Now, ma'am, I can't calculate this every time. If this specific question is given, then I'll calculate. So for me, to make it easy, we have a very simple trick for you, right? A very, very famous trick. That is, firstly, you have SPDF, right? It is 1, 2, 3, and this is 4. Firstly, you will write S 2 times, then PS 2 times, then you will write DPS 2 times, DPS, then you will write FDPS 2 times, FDPS, right? Now, here it is, S will start from 1, right? So it is 1, 2, 3, 4, 5, 6, 7, 8, right? P will start from 2. So it is 2, 3, 4, then you have 5, and this is 6. Oh, it's not 5. 5 is this one. 5, then you have 6, then you have 7. D will start from 3. 3, 4, 5, 6, yes. F will start from 4. So it is 4, then you have 5, yes. And now this is the increasing order of your energy, right? Okay. Okay guys, this is the increasing order for your energy. This is the energy increasing order, right? Okay everyone, clear everybody? Now, once you know this trick, you also need to know one more thing here. It is only applicable for, like if you want to see, okay, this thing was there. Now, if you see hydrogen atom, this is except for hydrogen, this is the energy. If you talk about hydrogen atom, then if N is same for hydrogen atom, if N is same, then E is same. E is same. So if I want to write down it for hydrogen atom, what will I write? Right? If I want to write this down for hydrogen atom, then what will I write? Because this also they ask you, okay? Okay, just give me a second. This is P, this is F, 4, and this is 5. Okay, so now here, as you can see, this will be equal, right? This will be equal. Then this 3D will be equal here. So 3D will come to this place. This will be 3D, right? 3D will be equal. Then 4S, 4P, 4D will be equal. I'll just write it here like this, not like this. I'll just write it here that 2S, 2P is equal, 3S, 3P, 3D is equal, 4S, 4P, 4D is equal, right? 5S, 5P, 5D, 5F is equal, right? So this is only for hydrogen atom. Only for hydrogen atom. Okay, this is only for hydrogen atom. Okay, yes everybody. Now second rule is Hund's rule. In Hund's rule, what we need to understand that what is the pairing. So he is saying that if you have a orbital, degenerate means having the same energy. You have an orbital, let's say it is P. Now you're filling the electron, you can't fill it like this. This is a wrong way. So how you need to fill it? Firstly, you need to, for example, I am filling 2 electrons here. I'll fill all the degenerate orbitals should be single electron should be filled there. Filling 2 electrons should be like this, 3 electrons will be like this, 4 electrons will be like this, 5 like this, 6 like that. Okay, so all the degenerate orbitals should be filled first with 1 electron. After that, you will pair these electrons, right? That is Hund's principle. Pauli exclusion is that you can't have, if you have this orbital, right, 3 orbitals. Now here, you can't say that you need to fill the electrons like this. 3 electrons you can't fill, right? You can't fill 3 electrons. You can't fill 2 electrons with the same spin. This is also wrong. This is also wrong. So opposite spin electrons, that means no 2 electron can have same set of all quantum numbers. That means N, L, M can be same. Spin cannot be same. Spin will not be same. And they will be opposite. The signs of these electrons will be, they will have opposite rotation. If one is clockwise, other will be anti-clockwise. Right? Okay. Okay. Yes. Now, let us see the shapes. See, if you talk about the S orbital, it is having a spherical shape, as you can see here, right? It will be having a spherical shape, right? But if you talk about, and this spherical does not mean this is actually a spherical, this is actually defined sphere. Spherical shape means that it is having electrons in a sphere, okay? It is having electron distribution in a sphere, okay? Like this, it is having the electron distribution, okay? Like this, it is having the electron distribution. So this means spherical. Spherical does not mean it is having a proper boundary or proper spherical shape it is having. It just means that electron could be present here, 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 here. In a spherical boundary, it can be present, right? Okay. Now, what is the shape for p orbitals? It is a dumbbell shape, as you can see. This is a dumbbell shape. This is a dumbbell shape. This is again a dumbbell shape, right? So now these three shapes are for Px, Py and Pz. If you talk about Px, so it is along the x-axis. Py is along the y-axis. Pz is along the z-axis. That is your p orbital shape, right? Next one is, guys, next is, yes, next is dx, dy, dz, right? It is having double dumbbell shape, right? Double dumbbell means this kind of shape, 2 here, 2 over here, right? So if you want to draw the shapes in 2D, I'll just draw the shapes in 2D. If you talk about dxy, dyz and dzx, this is dx square minus y square, dz square minus this. Now, if you talk about, if you see dxz, dxy, dyz, these are all between the axes. This sphere is between these axes, right? I don't know if you can see this in 3D, right? Okay, so now if in 2D I have to draw it, I'll draw it like this. This is between the axes. Between the axis, right? Between the axis. Between the axis, between the axis. Now, ma'am, what is this, ma'am? See, this is xy, then it will be called as dxy because it is between x and y. dxy. If it is yz, it will be called as dyz. If it is z and x, then it will be called as dzx, right? Now, if you have these orbitals along the axis, right, along the axis, let me show you in 3D. This is along the axis. This is how it is along the axis. As you can see here, the axis is coming from this ball, right? Right? From this ball, it is axis is coming out of that, right? That means it is along the axis, right? So now there are two things, that is dx square minus y square, dx square minus y square. So it is, if this is x, this is y, right? And if this is x, if this is z, then what we will say, this is along the z-axis and there is one electron cloud that is present here, right? This is called dz square. This is called dz square. From this also the question they can ask, right? Okay. Yes, very good. These are the non-axial, these are the axial orbitals, right? Okay. Now, next is nodes, antinodes. So, for nodes and antinodes, guys, this is a very important topic, right? This is a very, very important topic. Usually, students, they get confused in these kind of topics, okay? So, ready for nodes and antinodes, right? Nodes and antinodes, right? Okay. Yes, everybody? Yes. Now, if you talk about nodes, the formula is for radial or spherical nodes. There are two type of nodes. Why two type of nodes? Because when you solve this particular wave function, it will give you r and this theta and phi. Right. So when it is dependent on this r, it is called radial node. When it is in terms of theta and phi, it is called as angular nodes. Right. So now we don't need to get into all of this. We just need to understand what is important for us. Right. So this is radial, this is angular nodes. We will talk about radial nodes in detail. Right. Angular nodes in detail are not in your syllabus. Just the formula you should know. If they are asking you the radial or spherical nodes, it is n minus L minus 1. N is principal quantum number, L is azimuthal quantum number. Angular node, it is L. Total node, it is n minus 1. Right? Okay. Now, if you talk about two nodal planes are present in dx square minus y square, dxy, dyz, dzx. But there is no node that is present in dz square. This also they can ask you. Right? Okay, no nodal plane is present in dz square. Okay, yes. Now, let us see the graphs. Okay, now I am going to teach you the graphs. So, everybody be very, very like full Full focus here, right? So now there are basically three kind of graphs that we will draw, right? First is this psi versus r. This is psi square versus r. This is 4 pi r square dr psi square versus r. These are the three graphs. This graph is called radial wave function graph. This is radial probability density graph. This is radial probability function graph. Right? This is radial probability function. This is radial probability density. Right? So these are the three graphs that we have. Now, let us see the rules for that. Now, this is the important part for you. Now, this is the most crucial part here. Right? Psi, just remember these things. This is the maximum that they can ask you. If they really want to make the paper really tough for NEET 2025, then they will ask this. If the paper is easy, then they will not ask this question, right? Then they will only ask, if they ask you simple this thing, number of radial angular total nodes, then that will consider that paper as easy. But if they are making difficult paper, because we see, if you are aiming for aims, then difficult also you need to learn, right? So this is the difficult one. Now, not difficult for you, okay? Just remember these things. Just 1 second, you will be able to answer all the graphs, right? How? First is psi. The graph of psi can be positive or negative, means it can be upwards also, downwards also. It means it can be upwards also, downwards also. Psi square and this one, 4 pi r square dr psi square. I'll just write it here. And 4 pi r square dr psi square. Both are always positive, right? They are always and always positive, right? That means they will always go like this, right? Always like this. Now, very important, like psi is always, like psi is positive, negative, alternates. Psi square, in which you have psi square, because see, if you have -2, you square it, then you will have +4, na? You have +4 or +2 or -2, both will have +4 only. So that is why that is involving psi square, it will have positive side only, always, right? Then, for s orbital it is different, for others it is different, okay? For s orbital, here you can write and d also, and d orbital, and d orbital. Okay. Now, for s orbital, psi and psi square, that means first two graphs are at maximum. They will start from maximum. Start from maximum means they will start from this side. They will start from this side, maximum. At zero origin, you will have maximum there. But if you talk about the third graph, it will start from minimum. That means from this side. It will start from origin. It will start from the maximum, right? Then for p orbital and d orbital, all of them will start from minimum. That means origin. That means origin. So if you see the graph of psi starting from maximum, that is definitely a s orbital. They can give you graph and ask you to identify the graphs, right? Then psi and psi square, peak decreases. What do you mean by that? That if you talk about psi and psi square, for psi, we know that it is positive, negative, positive, negative, like this. It will decrease. For psi square, it is always on the positive side, so it can be like this. Okay. For psi square, wait a minute. Psi square always starts from maximum, no? Yes. Chalo, let's draw it like this only. So it is starting, the peak is decreasing. Peak is decreasing means like this. Peak is decreasing. But for third graph, that is radial probability curve. Here, the graph, the peak is increasing. The peak is always increasing, right? The peak is always increasing. Okay, understood? 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 Now, guys, tell me, are you able to understand these rules here or not? Everybody? Okay. This part is easier than Bohr. Then I'm happy to know that, right? Okay, everybody, let me just draw the peaks here. Now, understand one thing, the starting and the ending you will not take as node. This is the node here, if you want to see the node. This is the node, this is the node, this is node, this is node, this is node, this is node. Here if I talk about this is the node, this is the node. First and the last one are not the nodes. First and the last one are not the nodes. This one, this one, this one are the nodes. First and the last one are not the nodes anywhere. Right? Okay. Understood? Now let us see that what is the graph here. Based on this knowledge, how we can draw the graph. Okay. So if you talk about 1s here, right? The graphs, if you want to draw, then graph will be very simple here. As you can see, it should be like this, okay? Okay, yes, it is like this only. Dekho. Now, firstly, what you need to do, you need to calculate the radial nodes, because we are drawing the graph for radial nodes only. Angular nodes are not in your syllabus to calculate and all of that. Right, so radial node is n minus L minus 1. For 1s, n is 1. We know that n is equals to 1, L is equals to 0. So you put it here, 1 minus 0 minus 1, answer will be 0. That means there is no node here. So if you talk about psi for s orbital will start from maximum, right? Okay, it will have 0 node. So we will just touch this to this side. That is why here we can't say any node, because we don't consider the first and the last point as a node. So you have no node, right? Okay. Now, here again, psi square for s orbital also start from maximum. Again, it is decreasing. There should be no node present here, right? Now, for the third graph, that is psi square, 4 pi r square psi square. In this case, what you will have started from the minimum. For the s orbital, you started from the minimum, right? This start from minimum. So I have started this from minimum, and you need not have any node here. So that is why this and this are not considered in nodes, okay? First and the last point is not considered as nodes, okay? Now, to clarify this more, we have the graph for 2s, right? Now, for 2s, we know that the radial node is n minus L minus 1. What is n here? N is equals to 2, L is equals to 0. So, it is 2 minus 0 minus 1, that is 1. That means one node you need to show in the graph. See, for psi, it will start from maximum, but for psi, it is for minimum and it is for plus and minus both, right? So, when I draw the node, this is my node, this is my radial node. This is my radial, with pink dot I am showing the radial node, okay? This is my radial node. That one radial node that we have, right? So here this is not a radial node. So we have one radial node here that we can see. Positive and negative, why? Positive and negative because both sides. Now this is all positive and positive, only on one side, right? Only positive. Psi square is only positive. For S it is starting from maxima. So it is like this, it is going, and there is one node that you can see here, right? For 4 pi r square dr psi square, it is starting from always and always it will start from minimum. So it is starting from minimum, having one node here, right? And both are going in a positive way. Now, can you see the peaks here? Here the peak is decreasing. Here the peak is increasing. Here the peak decreases. Here the peak increases. Here the peak increases. Because as I told you that in case of this 4 pi r square psi square, peak will increase. In this case, peak will decrease. Okay. Okay. Now let us draw graphs for 3D. Okay, everybody. Let us try to draw the graphs for 3D. Shall we draw it? Okay, first we calculate the radial node here. Radial node is n minus L minus 1. N minus L minus 1. For this, what is the value of n? N is 3. L is equals to 0, 1, 2, S, P, D. That is 2. Right? So here just put the value, you will get 3 minus 2 minus 1, right? Here you will get 0 only. Alright, there is no radial node only. So let us choose something which will have radial node, right? Let us choose 4D here, okay? Let us choose 5D. Let us choose 5D. Okay, let us choose 5D here, right? Let us choose 5D here. Wait a second. Oh my God. Let us choose 5D here, right? So in this case, what you will get? What is the radial nodes? Everybody in the chat box. Here it is. N is equals to 5. L is equals to 2. It will be N minus 2 minus 1. Or you can just write it here. N minus L minus 1. That is 5 minus 2 minus 1. That is 2. So 2 you need to have here. This is your graph. This is the graph and this is the third graph, right? Firstly, understand one thing, this is psi square, this is 4 pi r square psi square dr, right? Now, let us draw the graphs here. For D, all of them will start from minima, right? Only for S, psi and psi square are from maxima, but here everything is from minima only. That means from this point only we will see all the graphs from origin only, from this origin only. If we talk about this one, 2 nodes you need to show. Peaks is decreasing, so it is 1, 2. How many nodes I have shown? 2 nodes I have shown here, right? And the peaks I have decreased, plus, minus, plus. 2 nodes that I am mentioning by this pink dot here, right? This is mentioning the 2 nodes here, right? Radial nodes, right? Radial nodes, okay? Not angular, radial nodes. Here you have, this is starting from the minima and we need to show 2 nodes and the peak should be decreasing. So 1, 2 and 3. Okay, so here these are the 2 nodes. These are the 2 radial nodes. Okay, understood? Now let us see the third one. Here the peak should be increasing. Okay, they should increase the peaks. So here again it will start from minima only. So it will be like this, 2 and 3. Right? If they give you, they will not give you anything complicated. They will give you very easy. I feel that they will give you S only, but still if they give you P or D, you can calculate, right? Okay, easy guys, simple. Okay, you just need to remember this particular thing, that is these rules. If you remember these rules, then things will get very, very easy for you. Okay, understood everybody? Understood everybody? Now, as you can see here, I don't know if this is visible to you or not, but it's just, okay, just for 1 second, I'll show you this thing, right? So here for 1s, as you can see, there is no node. For 2s, can you see this white boundary, this white line here, this white circle here? This white circle is the node. For 3s, you have this one and this one. These are the 2 nodes that you can see. For angular, now what is, these were the radial nodes. But when we talk about P and D, see for S orbital there is no angular node, but for P orbital, D orbital there are angular nodes as well. That's why I'm saying that angular nodes they will not ask you, most probably they will ask you S orbital only, right? So angular node is basically in the form of this cone, okay? This is like a cone. Whenever the orbitals are making that cone, that we say it is an angular node. So not in your syllabus in details, just remember that these are the angular nodes when they are making a cone here, right? In that way we can say angular node will exist, right? Okay, wow, looks so cool. Yeah. Okay guys, now let us just see the electronic configuration, right? Electronic configuration, you will fill in the increasing order of the energy, right? And the energy I have already shown you here, that what is the order of the energy. This is the order of the energy. It will be, we'll put the value as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 10 4p6, 5s2, 4d10, 5p6, 6s2, 4f 14, 5d10, 6p6. Then you have 7p2, 5p 14, 60, 10, 7p2, 8s2. Sorry, 7p6 and 8s2. Right, so this is how you're going to, make the electronic configurations here. Right, so I'll just show you that how to write the electronic configuration. Like for hydrogen, atomic number is 1, 1s1, 1s2, 1s2, 2s1, 1s2, 2s2. So this is the outermost shell is the maximum principal quantum number that you have. Here the maximum principal quantum number is 2. So these are the electrons, these are the valence electrons. Here these are the valence electron, here these are the valence electron. Valence electrons are in the outermost shell, that means in the maximum principal quantum number, right? How many number of electrons you have, right? Okay. Now this is how you will draw the electrons. Now everybody tell me, is there any confusion in the electrons? Anybody in the chat box, do you have any confusion in the electrons? Because I feel if you are preparing for NEET, right, and if you have if you have actually studied for last 6 months also, right, I'm not even considering last 1 year, I'm considering last 6 months also. If you don't know electronic configuration, that means you don't know inorganic chemistry. After this, I'll start questions only. Yes? No ma'am, no confusion as far as now ma'am. Okay, perfect. Right? So now, this is the electronic configuration. Now what you need to remember, how you will fill the electron. This is 1s, this is 2s, this is 2p. First you fill the degenerate orbitals. For example, I need to fill 5 electrons here. So I will fill it like 1, 2, 3, 4, 5. This is how I will fill the electrons. Now they are saying that half filled and fully filled are more stable. Half filled means this one, half filled means this one, and this one are more stable, right? Why? Firstly, this one is more stable because it is a noble gas, because the electronic configuration, the octet is complete. It should have 8 electrons in the outermost shell, it has 8 electrons. Only helium is a noble gas, which is duplet is complete. Otherwise, if octet is complete, that is stable. Half filled is also more stable. Now the question arises, why half filled and fully filled are more stable? The reason for their stability, wait a minute, yes. The reason for their stability are the symmetry. First is symmetry. Here I am just writing down the reasons. Reason first is symmetry. Okay. Second reason is exchange energy. So when they are in a very symmetrical manner, then they are more symmetrical, right? More symmetry. When symmetry is good, then stability is more always, right? In ortho and para isomers, always I told you that para is more stable. Why? Because of symmetry, right? Symmetry more, stability more. And more is the exchange energy. More electrons can exchange the positions, more will be the energy, right? Okay, that is why half filled and fully filled are more stable. Now there are exceptions. This we have drawn it from 11 to 20. Then you have from 21 to 30. Now this also is very simple. I'll provide you the notes. You can just go through them, very simple, right? Why we have written neon here? Instead of 10, we have written neon. Instead of writing 1s to 2s to 2p6, we have written neon, right? Instead of 18, we will write argon, right? We have written here. Instead of 18, we have written argon here. That is why 18 plus 1 is 19. This is 18 plus 2 is 20, right? Okay, so here also we are writing argon everywhere. And this is the most important electronic configuration for you, because this will be useful in DNF block and coordination chemistry and coordination chemistry and coordination chemistry. Because in coordination chemistry, you have to use from 21 to 30. That should be on your tips. Like, so 𝐂𝐡𝐞𝐤 𝐿, this is how you remember. And 21 to 30. But here you have two exceptions. One is chromium, other is copper. Now chromium was supposed to have 3D. It was supposed to have 3D 4s2, right? 4s2 3d4. It was supposed, because we know that 4s is filled first, no? So it should be 4s2 3d4, and here it should be 4s2 3d9. Okay, it should be 4s2 3d9. But what will happen, to gain more stability, one electron will jump here and it will become 3d5 4s1. One electron from 4s will jump here and it will become 3d10 4s1. How? Let us see this diagram here, that it was supposed to have 3d4 4s2, but because of the stability of half-filled orbital is more stable, that is why one electron will jump here and it will be 3d5 4s1. Right, so many students get confused here. 3d 4 ma'am, 4s, bacha, 4s will be filled first, 3d will be filled after that. Right, okay, understood? 4f will be filled first, 3d will be filled after that, but electrons will be taken out from 4s first and after 3d. That means 4s will be filled first also, the electron also will be taken out from 4s firstly. Right, okay, right, okay guys. The reason fully filled are more stable due to extra stability, lower energy, right? Okay, that is why P3, P6, D5, D10, 4, F7, F14 are more stable, right? This we will understand more in detail in inorganic chemistry, right? That I have already taught you, right? Okay, understood everybody? Everybody in the chat box. Now last one is your magnetic properties, right? So these are paramagnetic, means which should have at least one unpaired electron. Diamagnetic means all the electrons are paired here. If you want to calculate the magnetic momentum, right, that will be, that is dipole moment, that will be under root n plus 2 Bohr magneton, right? Usually the trick is, if you have one unpaired electron, it will be 1.7 something, right? 0.7, 0.8 something. 2 will be, if you have two unpaired electron, it will be 2.7 something. 3 means 3.8 something. 4 means 4.9. 5 means 5.9. Right? Something like this, approximately this kind of answer, 0.8, 0.9 type of answer will be there. Right? Okay, this is a simple trick, not to calculate this, rather just write the value as it is. Right? Okay. Yes, everybody. Okay. Shall we start the questions? Everybody in the chat box. Shall we start the questions? Or do you want to do the questions some other day? Because we have less time here, so I'll just take some important questions only. These are okay, chalo. So I'll not write, I'll just give you the, like, you know, in a fast way we will do the questions, okay? Yes? Yes, everyone? Chalo. Let us see that what kind of questions can be asked. First is the ratio. Very simple. The ratio of charge to mass of the electron in coulombs. That means E by M ratio of electron. E by M ratio of electron, guys. What was the E by M ratio? That is, everybody in the chat box, what is E by M ratio? Minus 1.76 into 10 raised to power 10 coulomb by gram. Okay, so answer is, okay, they are talking about not kilogram, they are talking about gram, so it will be 10 raised to power 8. Yes, so A will be the correct answer here, right? Okay, for kilograms it will be that, yes. Okay, now it will be 10 raised to power 11 na? Okay, so divided by 1000 it will become 10 raised to power 8, yes. Now, which of the following observation was not correct during the Rutherford scattering experiment? Which of the following observation was not correct during the Rutherford scattering experiment? Everybody, which of the following observation was not correct? Everybody in the chat box, which of the following was not correct? Most of the alpha particle passed through the gold foil undeflected. A small fraction of alpha particles was deflected by small angles, which was not correct. Most of alpha particles, yes. A small fraction of alpha particles were deflected by small angles, yes. A large number of alpha particles were bounced back, no. So, C will become the correct answer because that is the incorrect statement here. Okay, that is the incorrect statement. Next is, which of the following species is isoelectronic? Isoelectronic means same number of electrons it should have, right? So hydrogen is having 1, fluorine is having 9, so total 10. 7 plus 7 it is having 14. 7 plus 7 plus 1, which is isoelectronic with CO. Carbon monoxide is having 6 plus 8, right? So it is 14 only. So definitely N2 is isoelectronic, right? N2 is isoelectronic, right? How it is having 14? N plus N, positive means it is going to lose 1 electron. So it will be 13. This is 8 plus 8. Oxygen is having 8 atomic number, right? 8 plus 8. 1 electron, 9 means it is gaining 1 electron. So it will be 17. So only N2 is isoelectronic here. That is B is the correct answer. Very good. Next is the energies E1, E2 of the two radiations are 25 and 50. The relation between their wavelength will be, right? Energies are given to you, right? You have to calculate the value of wavelength. Everybody, E is equals to hc by lambda, E1 lambda 1, E2 is equals to hc by lambda 2, right? Then you need to see that this is 25. So you need to calculate the value of lambda 1 and lambda 2. So what you do, E1 by E2 equals to hc by lambda 1 multiplied by hc is multiplied by lambda 2. This will be lambda 2 by lambda 1, right? E1 is 25, E2 is 50, so that becomes 1 by 2 lambda lambda 2 lambda, wait a minute, that is lambda 1. So lambda 2 by lambda 1 is equals to 1 by 2. So here we can say lambda 1 is equals to 2 into lambda 2. So lambda 1 is equals to 2 into lambda 2. That is B is the correct answer. Okay. Lambda 1 is equals to 2 into lambda 2. Mine is coming out to be B. Right. So B is the correct answer. Okay. Yes, I think too. Yes, you thought right. Okay. Next question is, for given energy E, if you have an energy that is E in joules, corresponding wavelength is E is equals to hc by lambda. Apply this method here. E is given in joules. Okay. So put hc as this is in joules. So you will get this in meters. You have to convert it in nanometers. Right. Okay. So you can do one thing. Either you can just convert it into electron volts. How to convert joule into electron volt? Right. So 1 electron volt is equals to 1.6 into 10 raised to power minus 19, right? So just divide it by that, or you can just put this value. You can calculate, just put this value in joules. This is 20 into 10 raised to power minus 26, right? Okay, this is lambda. You will calculate this. E is 3.03 into 10 raised to power minus 9. You can calculate the value of lambda from here. That will be 20 into 10 raised to power minus 26 divided by 3.03 into 10 raised to power minus 9. Lambda will be in meters. So then you need to convert it into nanometers. And 1 meter is equals to 10 raised to power minus 10 raised to power 9 nanometer. Right? Okay. Totally depend. You can convert firstly this into electron volt and then you can apply that formula also. E is equal. You can also apply this formula, this in electron volt and this is nanometer 1240 and lambda in nanometer. So it's totally your choice that what you want to do. You can convert this into electron volt and then apply this formula and directly lambda is in nanometer, or you can apply this formula and then convert meter to nanometer. That is totally your choice what you want to do, right? Okay. So here, because let's not waste our time on calculation, waste my time on calculation. You have to do it in the exam, right? Ma'am, we will also not do it. You have to do it, guys. This I told you the direct formula only, right? You will get it as 656 nanometer, right? Okay, 656, that means D will be the correct answer. You can solve it. Calculation will be the part, right? Then you have frequency of the wave of light. Mu is given to be this, right? The wave number associated with this, see, C lambda, mu lambda is equals to C. So here they have given you the frequency. Frequency is equals to C by lambda. C is equals to 3 into 10 raised to power 8 divided by what is lambda. Lambda is, lambda you can calculate na. Lambda is equals to C by frequency. So it will be C is 3 into 10 raised to power 8 divided by frequency is 12 into 10 raised to power 14. This should be 12 into 10 raised to power 14, right, per second. Okay, so from here you can calculate the lambda in meters, right? Then wave number will be opposite of lambda. That will be 1 by lambda, right? Okay. So you just need to do that. Or you can just solve it like this, that lambda will be, that wave number will be 1 by lambda is equals to 12 into 10 raised to power 14, 3 into 10 raised to power 8 per meter. Okay, wait a minute, lambda is in meters. They are saying the wave number associated with this, no? So it should be per meter. Wait a second, frequency is 10 raised to power 14 or what they have given us? Frequency is what? 10 raised to power 14. Answer, they are saying that 4 into 10 raised to power 4. Okay, got it, because here you will get it as 4 into 10 raised to power 6. है ना? So this will, so this is so already neglected because they are giving it in meter and centimeter. This should be per centimeter per meter, right? So here this is in per meter. In centimeter, it will be 10 raised to power 4 per centimeter, right? So this is basically 12 into 10 raised to power 14 per second only, right? Okay. 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 Next question is the energy of the second Bohr orbital. Now we have the good questions. Energy of the second Bohr orbital of hydrogen atom is 3 this. Hence, the energy of fourth orbital would be. Energy of second orbital is given to you. Energy of fourth orbital they are talking about. Here they are asking you fourth orbital means n is equals to 4. Of hydrogen atom means Z is equals to 1. So, they are asking you this in joule per mole. Firstly, guys, we don't have any formula which is telling directly in per mole. So, firstly, you will calculate the energy in joules. The formula that you will apply will be in joules. Then you will convert it into kilojoules. Then you will, this will be per atom. This will be for per atom. If you want to calculate for Avogadro's number, so you have to multiply this by Avogadro's number and then you will get kilojoule per mole. Right? Okay. Okay, guys. 2005, your sister was born. At that time, this was the question that they were asking. So, this is again the formula, right? The constant part they have not taken. Why? Because they are asking you, see, E2 is given to be, if you talk about this is the constant part, this is the constant part, right? Like minus 2.18, they have not written that thing here. They have just written K here, right? Reason is, right, after this what they will do, firstly, okay, they have given you E2 energy, but you don't even need to get into this thing. Why we are doing this thing here? You can just directly calculate with the formula. I would not advise you to get into this thing. Just calculate this with the formula, right? Don't use this thing E2 this, then E4. just directly calculate this with the help of formula, right? That minus 2.18, that formula, right? Okay, the formula for joules, not the formula for electron volt. So basically you have two formulas, right? So don't use this formula. Wait a minute, where it was. Okay, wait a second. Yes. So don't use this formula, use this formula. This is only for joules, right? Minus 2.1 10 to the power minus 18. This is the formula that you're going to use, not the electron volt formula. Then you convert it into kilojoules. Then multiply this by 6.022 into 10 to the power 23. Okay? Okay, everybody? Okay? So now here what they have done, here they have just calculated this K as the constant because we don't know what is the formula for per mole, right? So that is why they have taken K as constant. They are saying for this value you can calculate the value of K here, right? Then put this K value here, directly you will get the answer in kilojoule per mole. It's only your choice. If you're not able to understand this thing, that how they calculated this, directly put the formula, right? Okay, directly put that formula, right? Okay, guys, understood now why here they have used this thing? Because we don't know for kilojoule per mole. They are saying that for kilojoule, energy for this in kilojoule per mole is this. So we have compared this and we have taken out the value of this constant K here, right? Okay. Now, next question is, based on the equation, that is this equation, are written, which of them is not correct? Equation can be used to calculate change in energy when the electron changes orbit. Yes, definitely, right? For n is equals to 1, the electron has more negative energy than it does for n is equals to 6. Yes, it has more negative, means that electron is more loosely bound to the smallest orbit. No. More negative energy, that means it is more tightly bound, right? The negative sign in equation simply means that the energy of the electron bound to the nucleus is lower than it would be if the electrons were at infinite distance. Yes. Okay, that is true. That negative sign simply means that the energy of the electron bound to the nucleus is lower than it would be. Yes, it is definitely lower because energy is increasing. As n is increasing, energy is increasing. So when you are decreasing the value of n, that is also decreasing. Larger the value of n, the larger the value of orbit. That means larger the value of n, larger the value of orbit radius. More the n value, more it will be having more size. Right? So definitely B is the correct answer. Right? Okay. Next question is, for Bohr orbit radius. Now they are saying you have a radius. For hydrogen atom, n is equals to 1. Hydrogen atom means z is equals to 1. Is approximately this. A naught value they have given you, right? Abhi to they don't even give you the value of A naught, right? They'll just ask you the radius for first excited state. First excited state means n they are talking about is 1 plus 1, that is 2. Whenever they are talking about excited state, add 1 to that, right? So first excited state means they are talking about 1 plus 1, that is 2. So here you can just calculate the value of radius by directly applying the formula here, right? Just apply the formula here. It is basically it will be, wait a minute, it will be n square by z square, right? And this is A naught. A naught is given to be 0.53 because they have not written here the formula. So I'm just writing this here for you, right? You just put it here, you will get this is n is second, na? N is 2, so it is 2 square. Z is 1, so it is 0.53. It is an angstrom, so it will be 4 into 0.53 angstrom. Right? Okay. Yes. So answer will be 2.12. If you multiply this, definitely you will get the answer as 2.12. Right? Then the next question is similar to this one. Radius, now they are asking you the radius of hydrogen atom. Radius of hydrogen atom in the ground state is this. Again, I am telling you that still they will not, now they don't give you the radius of ground state. They'll just directly assume that you know the formula, right? This was way before when they were giving you the radius, and this is AIPMT, right? The radius of the hydrogen atom in the ground state is this, the radius of Li2 positive. See here, Z is equals to 3, hydrogen, helium, lithium. N is equals to, what is the value of N? They are in the ground state. The radius for this in a similar state is, radius of hydrogen atom in the ground state is this. Ground state they are saying, na, ground state means N is equals to 1. Similar state means ground state only they are talking about, right? So just put the formula here, right? Z is 3 square, N is 1 square, right? Z is 3 square multiplied by 0.53, right? So it will be 0.53 divided by 9. 0.53 divided by 9 is going to be the correct answer, right? Okay. Yes, so it will be, I think so, that it should be something divided by 9. It will be a very small value, right? So I think it should be 0.17. Yes, 0.17. Okay, so approximation you can use here. Where the very small value, definitely these two are eliminated. From these two you have to calculate, right? So you can use approximation and give the answer, right? Okay. Now, next question is the electron energy, right? Okay, chalo. Now the electron energy of the hydrogen atom is given by this. Okay, that again they will not give you this in the exam. This you need to know by yourself only. That for hydrogen atom you have Z is equals to 1. That is why this is the value. Calculate the energy required to remove one electron completely from N is equals to 2. That means value for N is equals to 2 you have to calculate. What is the longest wavelength of the light in centimeter that can be used to cause this transition? See, firstly they are asking you calculate the energy required to remove an electron completely from N is equals to 2. So the sign will be opposite, right? Energy will be same, just put N is equals to 2 here, change the sign, that will be the energy required. Okay, so the energy required will, not given the answer here. Chalo. So the energy required will be your plus 2.18 into 10 raised to power minus 18. This is 2 square, that is 4 multiplied by 4. That will be the energy required, right? Then you have what is the longest wavelength? Longest wavelength means minimum energy, right? Minimum energy. Minimum energy means what is the longest of the light in centimeter that can be used to cause this transition. Minimum energy you need to have, right? Minimum the electron can go from which position? If N1 is 2, then N2 can be 3. That is the minimum energy, right? So you need to calculate this thing here, that is N delta E is equals to, what is the lambda here? So corresponding to this, what is the lambda? Okay, so what is the longest wavelength of the light in centimeter that can be used to cause this transition? So basically you need to apply that thing only, that is Rydberg only that you need to apply, right? From there you need to calculate the value of lambda, right? So here N square you have, this is 1 by N1 square, Z is 1 only, so it will be 1 only here, 1 by N1 square by 1 by N2 square. Just put the value of N1, N2 here. Rydberg you know that. Lambda you can calculate, right? Lambda will be equals to 1 by RH, right? And 1 by N1 square, 1 by N1 square minus 1 by N2 square. This will look difficult, it's very easy. N1, N2 you know the value, you can easily calculate this thing. 1 by RH, I told you, you need to take the value in angstrom. After that, convert that angstrom into centimeter. Right? Okay? Okay, guys? Chalo. Now, I am not solving full-fledged because otherwise it will take another 2 hours. Right? So, I am just giving you a hint of what they are asking you. Right? Then you have, according to the Bohr theory, which of the following transition in hydrogen atom will give rise to least energetic photon? Least energetic means, according to Bohr theory, which of the following transition in hydrogen atom? That means Z is equals to 1. Right? So, least energetic photon, energy should be very low. That means frequency should be very low here. Right? Which is going to give us the least energetic photon? Everybody. Which is going to give us the least energetic photon? So, if you talk about the lambda, E is equals to hc by lambda. Right? We know that least energetic means you need to see here the value of lambda, right? What you will get after these transitions. For this transition, for this transition, for this transition, for this transition. Now, from 6 to 1, right? From 5 to 4, then from 6 to 5, then from 5 to 3, right? So, these are your values of lambda that you will get from here. We know that energy is inversely proportional to lambda. So, more is the lambda, less will be the energy. But can you calculate? Very good. But can you calculate all of these things? Are you able to, like, do you need to calculate everything here? No, right? So, what we will do here, right? 1 by lambda, right? 1 by lambda, that means it is approximately energy inversely proportional, is inversely proportional to 1 by n1 square minus 1 by n2 square. Just calculate this value. Because see, your formula is 1 by lambda. We know that it is inversely proportional to E. So that means E is directly proportional to 1 by n1 square minus 1 by n2 square. Right? So just put the value C, which is maximum. E is directly proportional to 1 by n1 square minus 1 by n2 square. n2 square, just put this value. Here if you put 1 here, 1 by 1 minus 1 by 6 square, right? It will be 1 minus 1 by 36, and this is E, here it is 1 by 4, 16 minus 1 by 25, 5 to this, no, to this. So it will be 35 by 36. It will be 25 minus 16, something 5 plus 8. Wait a minute. 25 minus 16, 4, 5. 9 by 25, right? It will be something around. Wait a minute. Why are we even doing this? Least energetic photon, no. So we can directly see that, okay, there is one transition required here. Energy of this and energy of this, we can even subtract the energies here. Hai? We can even see the gap here. This will have the maximum gap. That is why the lambda will be minimum here. So I think directly we can say that this is the answer. Chalo, let's do this. This is 25 minus 1 by 36, right? Then you have 1 by 25, 1 by 9 minus, this is not how we should solve it because it is coming out to be even tough, but chalo, let us see. 36 minus 25, 5, then you have 4, 9 by, again it is coming out to be very, very tough. I think we should not solve it like this. Otherwise, it is coming out to be tough. Let me find some other way. Let me see. Wait a minute. Let me see how we can solve this theory. Which of the following transition of hydrogen atom will give rise to least energetic photon? Least energy we need to have. If you talk about 6 to 1, right, this is Okay, I'm just solving this with the help of diagram, okay? Because with calculation, though, it is very tough, right? Very long calculation, it will take you like really long time. So I'm just solving it with the help of energy diagram, right? Okay, till 6 we have 1, 2, 3, 4, 5 and 6, right? We know that for hydrogen it is minus 13.6, it is minus 3.4, it is minus 1.5, it is I think it is again 0.85 something, it is 0.5 something, right? So this is 1, 2, 3, 4, 5, 6. Between 1 and 6 it has a maximum energy gap, right? So the photon that will be released will be maximum, right? This is the right way. So sorry, because with that it was like very tough, है ना? With that it will take you like such a long time to solve that. So with the help of diagram only we will do this, right? Very large gap. Then you have from 5 to 4. 5 to 4 means this transition. 6 to 5 means this transition. Now I told you one thing, that as n increases, delta E decreases. That means if I talk about 5 to 3, it is this. 5 to 3, it is this gap. 5 to 3, it is this gap. So definitely you can see that if you're talking about maximum energy photon, so this will not be the answer, this will not be the answer, because here you're having this much gap, here you're having this much gap, right? So here you're having two gaps, here you're having 1, 2, 3, 4, 5 gaps, 5 energy gaps in between. So definitely these should not be the minimum. The question is regarding this one and this one. That means n is equals to 5 to 4 and 6 to 5. That is the question. Now, I told you that as n increases, delta E decreases. That means I talk about this delta E. This is having more value of n from 6 to 5. That means here delta E, if I take it as 1, if I take it as 2, then delta E of 6 to 5 will be less as compared to delta E of 5 to 4. Why? Because definitely as n is increasing, here n is less, that is why delta gap is more. Here n is more, that is why gap is less. That is why the answer is C. Okay, so let's do it from the diagram only. Let's not even try to use formulas here, because it will become very tough, right? Okay, so they have to use formulas only here, right? But we will not use the formula, okay? We will not use the formula. So I'll just write here, don't use formula. Don't use formula. Right? Okay? Chalo. Now, next question is, given mass of the electron is this, Planck's constant is this, uncertainty involved in the measurement of velocity with the distance 0.1 angstrom will be. Firstly, to convert this angstrom into meter, right? Then we know that delta X, delta P, or you can say M into delta P. M is given to you, delta V, H by, or you have to think it as equal only, H by 4 pi, right? Now delta X is given to you, it is as 0.1, right? You will convert it into angstrom, that is 10 raised to power minus 10 only, right? Then put the value of mass, put the value of this, then Planck's constant is given to you as 6.6 into 10 raised to power minus 34. Pi also, you know the value of pi, right? Okay, 3.14 you can use, or 22 by 7 you can use. Then calculate the value of delta V from there, H by 4 pi divided by delta X multiplied by M. Okay, so it is also a calculation based thing. Okay, again calculation is involved here, right? So you need to just do the calculation, so many calculations. That's why students find it tough, because of so many calculation. H, this value, okay, just don't forget to convert it into the meters, okay, because the options are given in meters. Options are given in meters, so don't forget to convert it into meters. Then put mass, then put the value of this, then value of pi, and you will get the answer. Okay? Okay, guys? Or do you want me to do the calculations as well? Huh? Now the orbital angular momentum of an electron in 2s. Now they are asking you the orbital angular momentum of an electron in 2s. Now, firstly, so I'll be very frank with you. Now they don't ask you question based on more calculations. Even in NEET, they don't ask you the questions. If you see the last year paper as well, they don't ask question based on like too many calculations. Rather, that's what I'm telling you, that you need to know the relation of radius with n and z, because they can ask you the ratios. They will try their best that they can also, you can like least calculation are needed, right? Okay, so that's my prediction that they will not ask calculation, because if they are asking chemistry, in chemistry they are asking mathematical calculation, then I think then the examiner was not like was not using the brain. I think if you want to ask the want to test the knowledge of chemistry, then just stick to chemistry. Then why you're giving so many tough calculations? Now this is purely calculation, purely calculation. It was not even a like something, a very tough question related to chemistry, pure calculation, right? And this was your old question 2006, but right now in 2025 I feel that less calculation and more conceptual knowledge they are focusing on, right? Okay. हाँ जरूर. The orbital angular momentum of an electron is 2s orbital is. 2s orbital, guys. Now these kind of question is what they focus more on. Less calculation, pure chemistry, right? Even in Bohr model, they will ask you the ratios, comparisons, relations of velocity, time is directly proportional to orbit number and atomic number. Like that kind of questions are more frequently asked now, right? So this is n is equals to 2 and L is equals to 0. They are asking you the orbital angular momentum. Orbital angular momentum is under root L plus 1, right? H by 2 pi. So here it will become 0. So orbital angular momentum will turn out to be 0 only, because L is 0 here, right? Okay, okay. Now 0 is the correct answer, right? Next is, which of the following pairs of d orbitals will have electron density along the axis? This is also a good question asked latest. See, latest question NEET 2016, not latest, but yeah, 10 years before, latest only we consider, right? So just the following pairs of d orbitals will have electron density along the axis. Electron density along the axis, right? So this to definitely will not have, right? This also will not have, this also will not have, right? Wait a minute, so pair of orbitals, this they have given the option, wrong options are given to you. Wrong options are given to you, guys. This should be z square, okay? Then the answer would be C, because here though nothing is the right answer, right? So here it should be dz square only, then because dz square and dx square minus y square are along the axis, right? So answer should be here, it should be dz square only, yes, right? Then next is 2019. So this I will consider as a latest question. See, they have shifted to quantum model and nodes. That's why I was telling you that go through the graphs, because now from calculation the focus is shifted towards these nodes, anti-nodes. More questions, new questions are being asked, right? The orbital having 3 angular nodes, 3 total nodes. 3 angular nodes. What is angular nodes? Angular node is L. L is equals to 3. 3 total nodes. That means n minus L minus 1 is equals to 3. If this is also 3, n minus 3 minus 1 is equals to 3. So it is n is equals to 3 plus 3 plus 1. Hai? Wait a minute. Orbital having 3 angular node and 3 total node. Achha, total node is 3. Okay. Total node means n minus 1 is equals to 3. So n is equals to 4. Yes, total node is 3. No, so n is equals to 4. So it will be SPDF 0, 1, 2, 3. Right? So this is they are talking about F orbital. This they are talking about 4. So it will be 4F. So answer will be C is the correct answer. Okay? Okay? Yes. So these kind of questions have more probability, like they will ask you these things. NEET 2016, two electrons occupying the same orbital are distinguished by. Same orbital, they are distinguished by which thing? In the same orbital. See, in the same orbital, they have same n, they have same value of L, even the value of magnetic quantum number is same. The value of spin quantum number is different, right? So answer D is the correct answer, right? Next is, this kind of question is also asked frequently. They are asking these kind of question. 2019, right? They are asking between 4f, 5p, 5f and 6p, arrange in the decreasing order. Firstly, let us see 4d, 5p, 5f and 6p. 5f and 6p. Let us see the n plus L value here. What is the n plus value here? N plus L value. As you can see, n plus n is 4, S is n plus L, no? So L is equals to 2. N is 5 and this is 1. N is 5 and F is 3. N is 6 and this is 1. So it will be, answer is, n plus L value is 6, 6, 5, 6, 7, 8, 7. So that means maximum, more the value of n plus L, more will be the energy. So maximum energy is of 5f. Then you have 6p. Now between 4f and 4d, more is the value of n, more is the energy. So here I have applied n plus L rule, n plus L rule, right? N plus L rule. Now here, more the value of n, more will be the energy. So 5p will have more energy as compared to 4d. So answer will be 5f, 6p, 5f, 6p, 5p, 4d. So answer will be B is the correct answer. Okay? Okay guys, everybody. Now this question they will not, wait a minute, atomic number, this is, so they will not ask you this question. Reason being, because this is actually a very, this they can ask in board exam, but not in NEET, right? Why I'm telling you that? Because right now, it's my duty to tell you what kind of question they can ask, what they cannot ask, right? So instead of this question exception, they will ask you exception from DNF block, not from copper chromium. That is a very old question, right? Okay, so electronic configuration of copper will be 1s2, 2s2, 2p6, 3s2, 3p6. Till here everything is same. This cannot be the answer, this cannot be the answer. It is 3d10, 4s1. So B is the correct answer. Right? Okay. Yes. Yeah, it's a very old question. That's why I'm saying this is before I was born. That's why I'm saying this question they will not ask you. Right? I think by mistake old questions are like here. Right? Some of the old questions by mistake I have taken, but let's go through that. Okay. So which of the following configuration is correct for iron? So for iron, the atomic number is 26, right? So till 3p, it will be the answer. After that, it will be 4s2, 26, no, till here it is 18. 10, 11, 12, till here it is 18. Till here it is 18. We need to add how many electrons more? We need to add 8 electrons more. So 2 electrons we will add here and 6 electrons we will add here. So D will become the correct answer. Okay? D will become the correct answer. 1991 candidate are very lucky. Such easy question they are asking. Actually, at that time, these were considered as tough questions. Why? Because at that time, no, they were not aware of so many things. These questions were tough at that point, right? If you talk about 10 years later or 20 years after NEET 2025, even NEET 2025 questions will be considered as easy. Hai na? Yes. Okay. So, guys, that was about structure of atom. Now, as we have started our NEET Express batch, right? So, I am taking the classes on NEET Express as well, right? So, basically, this series will continue in NEET Express, right? The series that I am teaching you here, it will continue in NEET Express. So if you want to avail this thing, right, in here, so I have taken just few questions, right? So in NEET Express batch, I'll take up, like a lot of, there will be, like here I have only one lecture. There I'll have 2-3 lectures for one chapter. That's why I'll take up one different practice session, like only practice session, only theory part. These kind of things will be taken in the NEET Express, right? So here I have taken like, okay, very few questions, right? But there I'll take not only previous year question, but also the questions that are related to the previous year questions, because we already had our DPPs that are already there, right? So what, because the team has worked really hard on analyzing past 10 years questions, and after that they had made new questions out of that, right? So those questions will be discussed in the batch, right? Okay, so here what you will get, first if you talk about the NEET Express Prime, you will get live sessions, online test and pedagogy, VBuddy. But I would suggest you go for NEET Express combo, because test series are very important for you. If you want to like really, because this is a point where you should also go for test series, you should have more practice as much as possible, right? So test series is also available here. So that is my like advice to you. If you are like want to have the revision plus the practice, because after 2 months you'll say, ma'am, I want to purchase test series also. So why not do this in this combo only, right? So go for test series plus the prime batch, right? But if you're like, ma'am, I have backlogs also, then I would suggest you this pro. Reason being, because here you will have hard copies of crash books and you will have unlimited access to doubt app. That means crash books also will be available to you, right? Then doubt app will be available to you. For example, you will have the access, your login ID will have the access to the doubt app. If you have any doubt, you can just log in there. You can just ask your doubt on video call also. The teacher can teach you, right? Okay, they can solve your doubts and queries 24/7. They are available, right? So that is my advice to you, that you should go for pro. If you know that you stuck in some questions, you find it difficult, right? Okay, so that person should be totally available to you. This is for those students who are not going to any tuition, who are not going to any offline, like they are not even going to school. This is for those students because they have no one to ask doubts, right? So if you have no one to ask doubts, you are doing hard work, your doubts are not getting cleared up, so that means something is wrong, right? But if you feel that, ma'am, I have maybe some tuition teacher, maybe my school teacher, they can answer my doubts, ma'am. So, but ma'am, then test series, so beta, they will not provide, no? So test series you need to go through, right? So I would advise totally depending upon what is your situation, you can purchase it, right? Okay, yes. Okay, yes. Okay, then bye bye guys. Take care. Okay. In case of least energy, which least energy? Which least energy, Soumya? Ask the doubts in Telegram channel. Okay, that's why I'm saying that doubt app is important for you for these little doubts. Okay, chalo. Okay, then bye bye. Take care. See you all in next session where we are going to do periodic classification, right? Or you can just mention which chapter you want me to do. Okay. Okay, bye. I'll do periodic classification only, by the way. Yes. Huh. I want to see those green hearts in the comment section because I can see that you guys are not commenting down. Huh? All the students that I can see live here, I want you guys to comment down on the video. That, see, I have been standing here for last 6 hours, right? So, if you're not appreciating, then that's bad on your part. Okay? Okay, then bye. Good night, everyone. Take care. See you all in the next session. Bye.